ছবিটা কই ছবিটা হ্যাঁ ছবিটা কই আরে
বুঝতে পেরেছি পরেরটা আচ্ছা আচ্ছা দিচ্ছি দেখা যাচ্ছে
হ্যাঁ এবার দেখা যাচ্ছে ছবি
বাবা এর মধ্যে ওই
আমাকে ভিডিওটাতে সেটাই জানিয়ে দিতে পারবে
আপনি এটা দেখেন আওয়াজ হচ্ছে কেন
এই নিলয় দুটোকে পাশাপাশি করা যাবে না রে যেটা আগে ছিল আর এটাকে দুটোকে পাশাপাশি করা যাবে না একই সঙ্গে ডিসপ্লে
দাঁড়া তাহলে পাশাপাশি
হ্যাঁ করতেই পারে ছবিটাকে ছোট করে দিলে ওইটাকে কপি করে দিলে এরকম করে দিলে
না ওই চেয়ারটা নিয়ে পড়ে যাবি তুই ওখানে দেখ একটা ইয়ে রয়েছে ইয়ের পাশে স্ট্রিমিং হচ্ছে কিন্তু
স্ট্রিমিং হচ্ছে এখন থেকে কেন
সেট করতে হচ্ছে না তুই ভিডিও ইয়েটা আওয়াজটা
আপনার ভিডিওটাকে ডিসেবল করুন এটা এডিটটাও যাচ্ছে ভিডিওটাকে ডিসেবল করুন আপনার ভিডিওটা
ভিডিও ডিসেবল করা আছে
আমি এখন বেরোচ্ছি, আমার তো এখন আর কোনো কাজ নেই।
Good evening, dear participants, honorable guests and students. It is Dr. Purva Chattopadhyay on behalf of Department of Home Science, the University of Calcutta. We cordially welcome you all to this mega international webinar series starting today till 7th September 2020 to mark the occasion of National Nutrition Week. However, yesterday we experienced the unfortunate loss of a most erudite and successful statesman of Bengal and India, our former President Sri Pranab Mukherjee. With a heavy heart, as our mark of respect, we dedicate the first session of this mega event to his memory. Shri Pranab Mukherjee was born on December 11, 1935 in Merathi, located in present-day Birbhum district of West Bengal, in a nationalistic family. His father, Shri Komoda Kinnor Mukherjee, was active member of Indian independence movement and was also a member of West Bengal Legislative Council during 1952 to 64 as an Indian National Congress representative. Sri Pranab Mukherjee, after his school education at Surrey, earned master degrees in political science and history and law degree from our university, the University of Calcutta. After briefly working as a clerk, then as assistant professor, and as journalist, Sri Mukherjee joined politics full-time in 1969 and soon rose to be one of the most stringent lieutenants of Srimati Indira Gandhi, the then Prime Minister of India. He was member of Rajya Sabha for 24 years and headed important ministries like defense, finance and external affairs from time to time. Meanwhile, he was also charged with the responsibility of Congress Parliamentary Party and the Congress Legislative Party periodically. He received Padma Vibhushan, India's second highest civilian award in 2008. His long association with Indian National Congress came to an end when he became the President of Indian Republic in 2020 in 2012 and formally took retirement from politics in 2017. He was awarded Bharat Ratna, India's highest civilian award in 2019. He received numerous other awards, honorary citizenship, degrees, and published many books, and a list is many books, a list too long to present here. Sri Mukherjee represented a rare genre, Sri Mukherjee represented a rare genre of Indian politician who was an extremely well-read person, loyal in spirit, astute and pragmatic in his approach, decent and down-to-earth in public sphere, and a sensitive person with broad spectrum acceptance. We join to pray for his departed soul, and we would now observe a minute of silence as a mark of respect to him. Thank you so much. Now turning towards the main event for which we have congregated here today. National Nutrition Week is observed every year from 1st September to 7th September to make people aware about the importance of nutrition for the human body and well-being. Good nutrition helps us to manage healthy weight, maintain the immune system, and provide for energy. The pandemic has actually accentuated its importance further in our life. On the broader level, it boosts the economy and, more importantly, the quality of human resource of a country. We have gathered here to celebrate the Nutrition Week, which from this year pertinently has been converted into Nutrition Month or Poshan Month with twofold objective, namely to focus on identification of children with severe and acute malnutrition and to engage with Poshan Ke Liye Paudhe, that is underlying importance of meaningful and self-sustaining home gardening. We have with us the chairperson of this session, the Honorable Registrar of the University of Calcutta, Professor Debashish Das. We have with us the guest of honor, the Dean of Postgraduate Faculty Council of Science, Professor Tulka Chattopadhyay, University of Calcutta, and distinguished guests, the Secretary of Faculty Council, Professor Amit Rai, and our head of the department, Dr. Pubali Dhar. I welcome you all again on behalf of our department. Welcome, sirs and madams. I would now request our head of the department, Dr. Pubali Dhar, to take over with the proceedings of the inaugural session. Thank you all so much.
একটা প্রোনাউন্সিয়েশন নিয়ে প্রবলেম আছে, আর সব ঠিক আছে।
মহা যন্ত্রণা হচ্ছে। বলছি কি, আমি একটুখানি ভিডিওটা চালিয়ে দেখে নিই। আচ্ছা, এটা মানে প্রেজেন্টিং করতে পারবো না? দেখে যান না কি হচ্ছে। এটা এই ডিনাই এন্ট্রি না করলে আমি প্রেজেন্টিং করতে পারবো।
হ্যালো পূর্বাদি, শুনতে পাচ্ছ আমাকে?
হ্যাঁ, পাচ্ছি। তুমি আমার কথা শুনতে পাচ্ছ?
হ্যাঁ হ্যাঁ, ঠিক আছে ঠিক আছে।
Okay.
ভিডিওটা শুনতে পাচ্ছি না কেন?
দেখা যাচ্ছে, শোনা যাচ্ছে না।
campus in the heart of the city
এবার শোনা
of
যাচ্ছে?
Kolkata,
শোনা
India.
যাচ্ছে।
ওকে ওকে।
As you move from the
মানে এই দিনটা একটু ঠিকঠাক রাখতে হবে। যখন ধরেন বন্ধ করে নিচ্ছে, এটা খেয়াল রাখতে হবে ওটা বন্ধ আছে।
শেষ না হওয়া অবধি পারবো।
Annalakshmi, can you hear me?
I can hear you. Can you hear me?
Yes, I can hear you. You can see me. Am I visible?
Just a minute. Let me see. I can see you.
Okay. Okay. Dear participants, there are already 97 and counting. We have thousands of actually registration. We are overwhelmed by the kind of responses. So I welcome you all. We will start sharp at 5:30.
Thank you, madam. I welcome Professor Tulka Chattopadhyay, our guest of honor today, and is Dean of Science, Faculty of Science. And I welcome you, madam, to this international webinar.
Thank you so much.
It hasn't started at 5:30. We will start just.
Okay, okay, fine.
Validi, will our secretary sir join? Amit Rai sir will join?
Yes, yes, he will join for a short period, but not yet. He hasn't joined.
Okay. Will you call our secretary sir? As he comes, then we can start with our proceeding.
Yes.
There are already so many participants, about 175 already joined.
Purbati, how many of them have joined?
177.
177 at present. Counting, continuously increasing, 178. Dear participants and attendees, you must be knowing that we have a overwhelming kind of a response for this webinar series. There are already more than 1200
Ma'am,
registered
1500.
participants. Oh, 1800, oh, 1500. Okay.
Yes.
Yeah, more than 1500 registered participants. So we all know that the limit for the Google Meet is only 250, and that is why the entire program will be live streamed on YouTube. So please don't feel bad if after some time it reaches the full capacity. Please log into the YouTube where you can see the entire and just participate in the entire proceeding.
So let's start, Purva. Start, Purva. Let's start.
Okay.
5:30.
So it's a momentous day today. We are extremely happy and we are extremely nervous also with such a grand event in our hands. So, good evening, dear participants, honorable guests, and students. This is Dr. Purva Chattopadhyay on the behalf of the Department of Home Science, the University of Calcutta. We cordially welcome you all to this mega international webinar series starting today till 7th of September 2020 to mark the occasion of National Nutrition Week. However, yesterday we experienced the unfortunate loss of a most erudite and successful statesman of Bengal and India, our former president, Shri Pranab Mukherjee. With a heavy heart, as our mark of respect, we dedicate the first session of this mega event to his memory. Pranab Mukherjee was born on December 11, 1935 in Merathi, located in present-day Birbhum district of West Bengal, in a nationalistic family. His father, Shri Yashoda Kinnor Mukherjee, was active member of Indian independence movement and was also a member of West Bengal Legislative Council during 1952 to 64 as an Indian National Congress representative. Sir Pranab Mukherjee, after his school education at Surrey, earned master's degree in political science and history and law degree from our university, the University of Calcutta. After briefly working as a clerk and then as assistant professor and as journalist, Sri Mukherjee joined politics full-time in 1969 and soon rose to be one of the most stringent lieutenants of Srimati Indira Gandhi, the then Prime Minister of India. He was member of Rajya Sabha for 24 years and headed important ministries like defense, finance and external affairs from time to time. Meanwhile, he was also charged with the responsibility of Congress parliamentary party and the Congress Legislative Party periodically. He received Padma Vibhushan, India's second highest civilian award in 2008. His long association with Indian Republic in 2012 and formally took retirement from politics in 2017. He was awarded Bharat Ratna, India's highest civilian award in 2019. He received numerous other awards. Um, Please keep yourself on mute. He received numerous other awards, honorary citizenships, degrees, and published many books, a list too long to present here. Shri Pranab Mukherjee represented a rare genre of Indian politician who was extremely well-read person, loyal in spirit, astute and pragmatic in his approach, decent and down to earth in public sphere, and a sensitive person with a broad spectrum of acceptance. We join to pray for his departed soul and would now observe a minute of silence as a mark of respect to him. Please join us, and I would request everybody to keep yourself on mute and let us just pray for the departed soul. Thank you all. Thank you all so much. Now turning towards the main event for which we have congregated here today. National Nutrition Week is observed every year from 1st of September to 7th of September to make people aware about the importance of nutrition for the human body and well-being. Good nutrition helps us to manage healthy weight, maintain the immune system, and provide for energy. The pandemic has actually accentuated its importance further in our life. In the broader level, it boosts the economy and, more importantly, the quality of human resources of a country. We have gathered here to celebrate the Nutrition Week, which from this year pertinently has been converted into Nutrition Month or Poshan Ma with twofold objectives, namely to focus on identification of children with severe and acute malnutrition and to engage with Poshan Ke Liye Paudhe, that is underlying importance of meaningful and self-sustaining home gardening. We have with us Honorable Dean, Postgraduate Faculty of Science, Professor Tonuka Madam, and she is our distinguished guest. We hope to have Secretary, Faculty Council, Professor Amit Ray with us. We also have our head of the department, Dr. Pubali Dhar, who conceived of the entire event. And we regret to say that our honorable register, he had actually wished us all the success for this event, but he is very busy with the faculty council meeting, which he has to organize tomorrow. So he could not make it today. So in his absence, we would just ask Professor Tonuka Chattopadhyay, our distinguished guest, to formally inaugurate the session as well as be our guest of honor. I welcome you all again on behalf of the department. Welcome, sirs. Welcome, madams.
Thank you, Pubali. I'm very much feeling happy, uh, and I invite here all the distinguished guests and speakers and my beloved students, and I welcome you all in today's program. Today's program have two aspects. One is the webinar. In recent days, we are passing through a difficult situation. As you see that we are all confined in our houses, and day after day, sometimes we feel that we are getting disconnected from all the people around ourselves. But this kind of webinar helps us to come out of this feeling, and sometimes we feeling no, that we are all connected, and the webinar is a great medium for this feeling of security. We all feel secure that because we feel that we are connected, and we have all our teachers and students, and we have a kind of I think networking. It's a very good thing that you have all organized this webinar in this kind of situation, which is very necessary for our refreshing our students to their university atmosphere. So we are feeling that we have a sort of academic environment around us. And the second aspect of the title of this today's seminar, which is mainly the topic of the nutrition. We all feel that there are many children and people around ourselves below poverty level who don't have nutritious foods, and they don't have any nutrition, so they suffer from malnutrition, and that actually leads to many kind of diseases that we are facing day by day. So from that point of view, the today's seminar is very useful, because we will be aware of what kind of food we should take for our nutrition, what kind of food we should not take for our nutrition. For example, we very often we take junk foods which are not good for our health, we know. But similarly, there are many types of foods which are not good for our health, in spite of their very tasty, and there are children who are suffering. So today's program will be successful if we feel for the children and the people who are suffering from this type of malnutrition, and we do something for them. I hope today's seminar will have some kind of direction towards that aspect. And I wish you success and all the speakers and students, so that the students you get some kind of information, some kind of instruction, some kind of future agenda from today's program. So I wish the success of today's seminar. Thank you all.
Thank you so much, madam. Now I would request our head of the department, Dr. Pubali Dhar, to come to the stage and thank madam, as well as invite Professor Amit Rai. Pubali Ji.
Welcome delegates, my colleagues, and my dear students. And I also welcome Dr. Amit Ray, our secretary, faculty of Home Science, Fine Arts and Music. I am thankful to Professor Unuka Chattopadhyay. She has accepted our invitation and and have joined the inauguration. In this international webinar, this organized by the Department of Food Science, University of Calcutta. It will be a 1 week long program, and yesterday the entire nation was in shock after hearing the news of sad demise of former President Sri Pranab Mukherjee, Bharat Ratna. We are dedicating today's program as a tribute to late Sri Pranab Mukherjee. Now, I want to talk a little about nutrition. Why I have thought of this type of webinar with people, with speakers from different uh, domains, from economics to food technology, from food processing to food packaging, and everything and many things will be covered in this webinar. This relationship between food and the consumer might look simple, but in reality, it is multidimensional. And the first dimension of this journey, embarked by food ingredients, is from farm to the plate and is regulated by psychological, socio-cultural, and demographic parameters, as well as economic planning and policies. Food packaging, distribution, security, availability has a direct influence upon consumer preferences and choices. Furthermore, when food enters inside a living system, the interaction of this ingested food with the various organs and glands and biomolecules, such as enzyme, protein carriers, resident microbial community, and overall physiological and metabolic condition, as well as the genetic constitution of the host, will determine the ultimate fate and outcome of the ingested food. Substantial knowledge regarding the chemistry, biophysical, biochemical properties of food becomes mandatory as it influences the process of nutrition. Therefore, to understand nutrition science truly and completely, knowledge regarding all these aspects becomes essential. The entire scope of nutrition science therefore encompasses barriers of both science and humanities. It summons an immense scope for holistic, multidisciplinary research. I will hand over to Anna Lakshmi, madam, for to say some words on National Nutrition Week. Anna Lakshmi, can you hear me?
Yeah, I can hear you. Good evening, everyone. We have come to the end of the inaugural session. I won't take much time between yourself and the eminent speakers. I would just like to tell you a
Just
few
a minute,
words on.
Anna Lakshmi,
Yes,
just
yes.
one thing. We have missed Professor Amit Rai. Just let him say a few words
Yes,
encouraging
he
us,
has
and
entered.
then you just
Okay, 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 okay,
culminate the session.
okay, okay, okay.
Sorry, Purva. Amita told me that he will not speak. He will come to the dais, but
Okay,
not speak.
then it's okay. I
Okay.
take this that sir has already wished us success, so it's okay. Anna Lakshmi, please carry on.
Okay. I would just like to brief upon the history of Nutrition Week celebrated in our country. The National Nutrition Week is celebrated the first week of September every year for the last 4 decades. It was first organized by Ministry of Women's and Child Development Food and Nutrition Board in 1982. National Nutrition Week is celebrated with an objective to raise awareness on the importance of nutrition, which has an impact on development, productivity, economic growth, and ultimately national development. So, for the last few years, the week long celebration was extended as National Nutrition Month celebration. I would also like to just outline the topics to be covered in today's webinar. Nutrition has to be secure to each and every individual on this earth. But due to the factors like food scarcity and growing population, the issue of food security has arisen. For this reason, researchers have been searching in the area for new food for feeding the people. In this search of new food, scientists have also been trying to give proper nutrition through the food developed by dealing the bad and good effects of the nutrients present in the food itself. As well as these scientific inputs have been taken up with the help of the public education educators to convey the marks for proper intake and utilization of the food. So with these few words, I would call upon Amrita to introduce our first speaker, Dr. J.N. Arthur Moses. Thank you. Amrita?
Yes, madam. Greetings and a
Anna,
very
now, one minute. Let
okay.
me show the video on, and he
Okay.
hasn't joined yet. Joined. So let us play the video, and
Okay,
then
ma'am.
on the
Sure, ma'am.
department.
Sure. Okay, ma'am.
Pubali, I like to have your kind
Yes.
permission that I have
Okay.
some other
Thank
things.
you, madam.
Okay.
Thank you very much, madam.
Our Department of Home Science
University of Calcutta is situated in the Biharilal campus or VL campus in the heart of the city of Kolkata, India. As you move from the main gate to the departmental building, trees, bushes, flowers will welcome you through the 300-meter boulevard of the campus.
Excuse me, Puvali. Puvali.
The home science department, formerly known as the Biharilal College of Home and Social Science, was established in 1957. Post-graduation course in food and our Department of Home Science, University of Calcutta, is situated in the Biharilal campus or VL campus in the heart of the city of Kolkata, India. As you move from the main gate to the departmental building, trees, bushes, flowers will welcome you through the 300-meter boulevard of the campus.
এত লোকে
The Home Science Department, formerly our Department of Home Science, University of Calcutta, is situated in the Biharilal campus or VL campus in the heart of the city of Kolkata, India. As you move from the main gate to the departmental building, trees, bushes, flowers will welcome you through the 300-meter boulevard of the campus. The Home Science Department, formerly known as Biharilal College of Home and Social Science, was established in 1957. Post-graduation course in food and nutrition was introduced in the year 1974. Gradually, the college expanded and was transformed into Department of Home Science of Calcutta University in the year 1982. In 1996, another important postgraduate course in human development was introduced. VL campus of university covers an area of 4.2 acres, approximately a lush green exotic campus with lots of rare species of trees such as taobao. The place is picturesque, enchanting, and with rich woodland-like environment with low level of pollution. The campus encompasses a small garden of medicinal herbs and shrubs for research purpose. Different varieties of tulsi and other herbs and shrubs are available. The departmental library has a stock of more than 18,000 hard copies of books related to domains of nutrition, food science, food technology, physiology, biochemistry, food biotechnology, psychology, sociology, and many others. E-library has access through University main server. The department possesses various state-of-art facilities, equipments for carrying world-class research activities, keeping in pace with the scientific fraternity throughout the world. Research focuses are nano-food technology, waste utilization for the production of value-added food products, search for bioactive components from various indigenous sources, their therapeutic roles, nutritional evaluation of unconventional foods, nutritional status of economically backward classes like tribes living in villages. Students are trained to work for the society at various levels where they directly communicate with the people. Trainings and workshops were conducted along with NGOs. Seminars, lectures of distinguished people from various interdisciplinary fields are organized throughout the year. Collaborative research is going on with other premier and world-renowned institutions like NICET, Kolkata, Saskatchewan University, Canada, Indian Institute of Cerebral Palsy, various NGOs, and other departments of the University of Calcutta. Thank you. Stay healthy, stay safe.
Thank
Thank you, Kubali.
Thank you, Dr. Professor Moses. Our speaker, Professor Moses, has joined us, and we are so. Purva, please introduce him, and Amrita.
Yes, madam.
Yes, introduce him.
Thank you, madam. Greetings and a very warm welcome to all of you on the first day of the international webinar series organized by the Department of Home Science, University of Calcutta on the occasion of National Nutrition Month 2020. There has been a change in the list of scheduled speakers. Unfortunately, our first speaker, Dr. Anantha Ramakrishnan, Director of Indian Institute of Food Processing Technology, will not be able to join us due to unavoidable circumstances. But we are grateful to have Dr. Jean Arthur Moses with us, who has agreed to join at such a short notice. Without further ado, we move on to today's first lecture with Dr. Jean Arthur Moses. Dr. Jian is presently working as an assistant professor and head of the computational modeling and nanoscale processing unit at Indian Institute of Food Processing Technology, Hanjapur. He received the gold medal and the best outgoing student award for his outstanding academic performance in both graduation and masters. Dr. Jian had been working as a graduate research assistant in the University of Manitoba, Canada during the course of his PhD from IISPT. He had received DSC SCRB Early Career Research Award, Dr. V. Subramanian Best Scientist Award, ICFP Young Scientist Award, ACRB ITS Grant, Grant for Dissemination of Innovative Technology, and so on in various technical platforms. He has authored over 90 publications with 547 citations in reputed journals, popular magazines, and books. In the year of 2019, he had published a detailed review describing the applications of 3D printing in food processing. Just a few months ago, his research on 3D printing of egg yolk and rice with rice flour blends got published. We feel lucky enough to have the opportunity to hear Dr. Jayan on food 3D printing. Audience, you can put the questions related to the lecture in the chat box. It's the time to grab the first lecture in our lecture series. Welcome, sir. The platform is yours now.
Hello, everyone. And for today's lecture, I want to thank the organizers for inviting. And as Madam was sharing, unfortunately, our director, he could not join now. But anyways, I'd be speaking on a topic which he is in, the research head, and that's on food 3D printing. So to begin, just give me a minute. I'll try sharing my slides so that you can all see it. Yeah. So I hope you can see my slides clearly. And so good evening to one and all. And today's talk is on food 3D printing. So before we speak about food 3D printing, we need to understand what 3D printing is, because this is a term that, I think it's just picking up in a lot of fields and slowly coming into the food sector as well. Take a look at some of these images here. This is a 3D printed house, a 3D printed car, 3D printed musical instruments, very complicated jewelry, 3D printed, human organs that are 3D printed, movie props that are 3D printed. So the good part is, this house was built in less than 6 days. Or this car, it's not just some toy. After the printer prints it, you can put in your key and then start driving the car. Or this jewelry, it's almost near impossible for someone to do it quickly to bring it to this level of design. But a 3D printer can do it. Or any kind of customization, character A in a movie and character B in a movie, character C. You have so many characters, and each of them have individual requirements for appearance. For each scene, they have to change. A lot of things happen, and 3D food or 3D printing works really good for all these applications. So now the question is, what can food 3D printing do, or what can 3D printing do for food processing, or for us who work in food science, food technology, nutrition, and all of the allied fields?
Sir, please press
Some
the
of these
hide
points
button. Sir, please press the hide button. Hide button on your screen.
Yeah.
Thank you, sir.
Thank you. So, yes, I've done it. Thank you. So some of the applications of 3D printing in the food industry. The first one, particularly for all who are related to food and nutrition, is to understand about the demand that consumers have. Everybody wants to have different foods. Everybody, no one wants to eat the same kind of food every day. You want colors to be different. You want textures to be different. You want the taste to be different. And based on age and based on working profiles, you want the nutritional requirements to be different. There's a lot of requirement from the consumer side that forces food technologists or nutritionists to look into the angle of how you can cater to such a big requirement that the consumers put forth. And 3D printing has the ability or the capability to come up with a novel range of food that not necessarily is already available, or it can be an available food that is getting printed, or it can be a newer version of the food. This slide explains about some of the broad applications or the different types of 3D printing processes. The first row that speaks about 1, 2, 3, 4, all of these, they are the type of printing processes. These are the type of printing processes that are used in food. The other three are not actually relevant to food, but I'm also trying to cover the broader application of 3D printing, because we did not start 3D printing in the food industry. It took its first origins in other fields, including automobiles and metallurgy and all of those fields. So among these four techniques, the fourth one, bioprinting, is more relating to printing live cells, organ printing, and it has its lot of biomedical applications. The third application, that is material extrusion or extrusion-based 3D printing, is the most popular method of food 3D printing. When you speak about food 3D printing, it's not just like how you print, documents. You have an inkjet printer or a laser printer that prints. It's not just stopping with a 1 dimension or a 2 dimension. You have 3 dimensions, meaning it also has a height. You can, the X, Y, Z axes. So basically, you can, shape your product accordingly. So there are 3 important considerations that you have to remember. The first one is the printability of the product. Can the product be actually printable? Second is the applicability. Once you print it, can it be used, or what is the application range for this product? And the next one is, once you print it, some foods, like for example, chocolates, can be printed to beautiful designs. You can just have them message. But if you print rice flour, after the printing process, everybody has their own palatability preferences. Might be it has to be baked, might be it has to be steamed or boiled, or so there is a post-processing requirement. And so food 3D printing basically holds all of these in a wider umbrella. And when you speak about whether the food that I'm speaking about is printable, there are 3 basic tests. It's the 1 dimension, 2 dimension, and 3 dimension test. I think the simplest form is when we think of indigenous traditional Indian foods. There are a lot of extrusion, homemade or hand extruders that you use, and you basically want the dough to come out of the nozzle in a proper consistency. It has to be a continuous thread. You don't want the thread to break. And if you try to connect it with another geometry, it has to connect. If you start putting it layer over layer over layer, you want the ground layer to still remain intact. You don't want the ground layer to collapse. This is the same logic that works in food 3D printing, but now we have automized, we have involved automation, and you're not just restricted to one particular die or one particular geometry. You can go to any level of customization. So speaking about the printing process, there are 2 columns that I want to highlight here. The first one is the product. The product is actually put into the printer's head, which is more like a nozzle, and then it is sent for printing. What makes food 3D printing unique compared to a normal extrusion process is the automation involved. You have the facility to create your own geometry. You can either put it into a CAD software and create a geometry, or you can scan, you can use 3D scanners. You can print your own body. You can scan your face, and then you can give it as the geometry so that the printer prints your face as such. So either ways, once you create the geometry, you convert it into an STL file, which is a stereolithographic file, and then you send it to a slicing software where this geometry is sliced into multiple layers of G code and N codes. So these codes are then passed to the printer head, and then the printing process happens. With your required geometry, you're able to print different foods. The food is getting printed in your geometry requirement. And some foods might require post-processing, as I said. It could be drying, frying, boiling, baking, steaming, or any type of post-processing to, based on consumer demands. So all of this happens, right on the printing platform. And we must accept that in India, all the work on food 3D printing, at least the research side, we started it just in 2019. So we're just 1 year of R&D in India in food 3D printing. And so at IFPT, we have two different food 3D printers. One is a single head food 3D printer, where your material is actually fed into this nozzle. And all this nozzle is controlled by computers, so you're able to print it, the design that is required. The other one here is a multi-head food 3D printer. So take a look at this. This is a geometry that you have actually created. It's a very simple geometry that I've showed here. And this is a multi-head 3D food printer. It has 4 heads here, all 4 heads printing different food materials. And you have the provision also to control the temperature in the printing process. You could, have each nozzle printing different geometries, like somebody wants Tom and Jerry, somebody wants Doraemon or something like that. Or if the kids want something specific, you could do it. So each, printing process can be customized based on consumer requirements. There are 2 other important techniques that can also assist food 3D printing process. One is electrospinning and one is encapsulation. Electrospinning is an electro-hydrodynamic process, and most of its applications are into material science, into biomedical, and all of those kind of fields. But in food 3D printing, you could use the concept of electrospinning for producing nanofibers, which can actually strengthen your matrices. You could also use encapsulation-based approaches to have higher bioavailability of your nutrients or nutraceutical ingredients that you are actually 3D printing. Now, speaking about the application range, this is something of interest, and I mean, we all will be curious to know what can actually 3D printing do. It's not just the shape, it's not just how it looks, but it's about how well you can provide nutrition. So speaking about personalized nutrition, chicken meat does not have fiber. You're trying to take in fiber from mushroom or from indigenous sources like millets. You put it into the 3D printing material supply. You are able to get post-processed fried chicken nuggets or chicken meat, which is fiber enriched. So I mean, that's an option. Now, if you want to increase iron for somebody, you can put that particular person's food with enhanced iron. Or if you want to reduce the protein, increase the protein, you can play around with the level of customization. Another application is the delivery of nutraceuticals. These days, everybody speaks about immunity and immune boosting, and we all, very, aware about the potential of Indian spices or Indian nutraceuticals like curcumin and all of them. You have the capabilities to put them into your food matrices and 3D print them. You can also deliver functional ingredients, probiotics. Probiotics, this is a study in which we had dried probiotic powders and then we had incorporated into the material supply, and you are able to get snack with live probiotic cultures. Another application range is the waste that can be utilized. Rice husk or sugarcane bagasse, for example, you can convert them into a printable form to make them as biodegradable cutlery and packaging casings. Can we replace single-use plastics that come with chocolates and all of them? Because you have the requirement to customize a heart shape or a diamond shape or something like that. You can do it with 3D printing. This is another application where you have potato peel, and imagine making foods out of potato peel. I mean, everybody says, the moment you say peel, they say a lot of people assume it as, pure waste, and nobody wants to eat foods that are made out of waste. But when you print them, here we've tried to print peel noodles. So when you print them, the consumer has no clue, but the consumer actually appreciates, that a lot of resource that actually just gets dumped into the environment is now being utilized. We also have another study in which we have used grape pomace and broken wheat. We converted them into cookies with, with functional benefits. So this also speaks about sustainability in an industry. When you try to actually dump grape pomace, you're trying to find out or use 3D printing as an option for cleaner production, for reducing waste in an industry. Now, before we end, there are three important categories of food material supplies. The first one is natively printable. These are materials that can be printed as such. You don't have to do much. I mean, this is a study with indigenous composite flour. We've used some Indian millets, and we had printed 3D snacks and post-processed it. Now, you also have other natively printable materials like chocolates, cheese, rice starch, or potato starch, tapioca starch. All of them can be printed as such. The next class is non-printable foods. You just cannot print them as such. You need to do some pre-processing. You might have to heat them, you might have to coagulate them, you might have to add other additives to make them printable. You might have to add hydrocolloids to improve the rheological characteristics to make them printable. Here we printed egg white, egg yolk, a 3D printed egg that's not going to break, that's not going to spoil. That's the task. And this shows about the range of process optimization studies we did. Some work, some don't work. The study is taken up to understand which printing condition works best for our printer. Is also the third kind of classification of food materials, which is alternative food ingredients. So foods like mushroom, insects, proteins that is picking up these days, algae, seaweeds, lupin seeds. A lot of these materials, like for example, this was a geometry, and this is a 3D printed butterfly, and this is after post-processing, that's after the frying process, you get 3D printed butterflies. So now, before I conclude, there's also the other fascinating field, which is called as 4D printing. So that's something that's more interesting because once you have a 3D printed object, now the next task is on 4D printing. So the fourth dimension, so when we speak about 3 dimensions, it was about just about X, Y, and Z axes. So it has a length, it has a breadth, and it has a thickness. When you speak about fourth dimension, it speaks about time as the dimension, and a change in color, or a change in pH, or a change in a shape, a change in some parameter that the consumer can see based on time. So with respect to time, we've done a study using curcumin. The same would work for anthocyanins. When you have changing pH, you see how the color actually transforms. Or you have shape-changing foods. The food is of a particular shape. You put it in your mouth, and then immediately the shape changes. Or you have a different feel. The idea of 4D printing is actually to involve the consumer. You attach yourself to the consumer. You're trying to, like instead of having cornflakes with all of them in the same color, imagine you pour milk into your bowl and you get, rainbow colors or something. Kids would love it. So the task of 4D printing now is to connect the industry or the 3D printing industry with the consumers. So before I conclude, I must speak about what's more important is about what's the state in India. In India, we are in the research stage, and there are lots of MNCs that are working on food 3D printing. One of the biggest challenge is the scalability, because most of the existing processes are very slow, and we are in the primitive stages of research, and we must be confident that this technology would pick up in the very near future. It's already commercialized in a lot of countries, and we should hope that Indian R&D would, be soon taking it up to greater heights. With this, I want to conclude this presentation. I want to thank the Ministry of Food Processing Industries and my institute, my director, and my students here at the department. Thank you so much. I'd like to see if there are any questions here. Just a minute. Yeah, so I'd like to take some questions. Okay, there's a question on the cost of food used in 3D printing technology. So basically, this is just the customization level goes up. Like for example, you want to go to an industry and a bakery, and you have you want to print birthday cakes. I'm not speaking about faces getting printed. No, that's part of 2D printing. But this is 3-dimension printing. Assume you want to have something like doves or hearts or candles or some 3-dimensional objects on your cake. The baker man is going to charge you heavily because it's part of customization. And so what could actually be done is use a 3D food printer, which can actually, do this work. And then, you want a card to be printed, the printer can print it. You want something else to get printed, you can print food in that particular, design or geometry. So, I mean, that is what food 3D printing can offer. So, I accept the equipment cost and the intellectual property of the person who is involved in 3D printing. I should say that the cost remains the same in terms of the material. The next one is, can a food and nutrition student work in this field? Of course, I am a food engineer and I'm working in this field. And a lot of people in food and nutrition, including home science, including different disciplines of food, are working on this field. And we must strengthen food 3D printing research in India. So yes, for that. And what are the advantages of 3D printing food is, I think you can go for unmatched level of customization, not just in terms of appearance, in terms of, in terms of nutrition. And I was giving you an example of making, from potato peel, we make noodles. So the conventional noodle process has, for example, 8 or 9 steps. Using 3D printing, your process becomes simpler. It becomes like 6 steps. So 3 steps. So there's a time saving factor as well, which the industry would appreciate. So I'm trying to say that, 3D printing has numerous range of applications. And the next one is, what are the disadvantages of 3D printing technology for agriculture nation like India? I would say there is nothing. I would say that Indian food processing sector is growing very fast, and we in India must strengthen research, and the IFPT is working on different aspects of food under the Ministry of Food Processing Industries. So, we all have to join together and, take up such technologies to the next level, because they have been explored very well in different foreign nations. And, we have great minds in India. We should all be doing this better. How does 3D food printing work? I think I've explained it. Do you provide any training? Yes, we do provide. At the moment, we are, we're not offering, but in another month or something, we would be resuming with, full-fledged food 3D printing training. Do you think 3D printing will be the future of packaged ready-to-eat foods? I would not say that this is just the future. Or I would not say that food, imagine you have grinders and mixers today in every home. There would be a day when every home has a 3D printer. Your mom wants to make one particular food. Dad doesn't like that food. He makes something else. At the same time, the son makes something else. The kid makes something else. So, your mom or the person who's cooking at home, it's a task to prepare different foods for everyone. Still, they do it. But now a food 3D printer can do it at convenience. So that's the future of food 3D printing. When we speak about packaged ready-to-eat foods or food processing as such, I would say that food 3D printing, we should view it as a technology to complement existing food processing practices. It's not a competitor. It is something to complement in terms of already you have wonderful processing techniques. We're going to support it with customization. So yes, you can customize your package as well. That's a part of the answer. And sir, 3D printing has visual advantages, but would it be expected taste? Yes, you can go for the taste. So if you want to vary your salt content, your oil content, or your sugar content, you can do it accordingly. You can modify the taste. Interestingly, like for example, dysphagia is a common issue when people have issue in swallowing food. So you can modify the texture of food in such a way that people with dysphagia can conveniently swallow foods. I mean, I'm trying to highlight that there are other uncommon applications or the benefits of food 3D printing. So there's the other thing, like for example, when you're trying to print meat. So if someone says, no, I don't want so much of fat, I want lean meat to get printed. So you could use your 3D printing technology to actually, with different nozzles, one nozzle pumping in the protein and one nozzle pumping in the fat, the lipids. You could actually, customize, play around with the nozzles, the flow rates of the, material that is coming out. You can create 3D printed meat based on consumer requirements. So I'm trying to say that you can meet requirements in terms of nutrition, in terms of taste, in terms of texture, yes, 3D printing will do it. It's an information. Okay.
One thing, Professor Moses, is there application of heat in 3D printing? Are you applying some heat? Temperature is increased, or is there an application of heat?
Okay, so this question, there are two types of, what I was trying to speak about today is mainly focusing on extrusion-based 3D printing. So just like how you have, cold extrusion, hot extrusion, normal extrusion techniques, like how pasta or vermicelli or something like that is made, and how, other extruded snacks are made. You do have cold extrusion and, hot extrusion in food 3D printing as well. So foods like chocolate, need hot extrusion, because if it's cold extrusion, then the chocolate doesn't even flow out of the nozzle. Foods like rice paste, sometimes you can flow it out, but if you want a particular consistency, then might be you'll have to look in for hot extrusion. So the need for heat depends on the product. So if your product requires heat, if your product requires semi-gelatinization, then you can say yes for heat. Otherwise, just turn off the heaters and run the 3D printer.
It's a new form of making jalebi.
I would say
jalebi is made in the restaurants and small shops,
yes.
and you are making it with technology.
Yes, so it's not just about the jalebi shape. You can go to any level of shape. And it's not just about the shape. Like, for example, if you want to enrich, the iron levels by some percentage for person A in your jalebi and percentage B in for the next jalebi, you could go for any level of customization in that as well. There are also 3D printed packages. Like, for example, you can have, you want to gift someone or something in a package, you can have your name engraved 3D printed. So basically, it's not just stuck to the food material. You can also go for 3D printing of the packaging material.
Yes, and you can use nanotechnology also.
Yes, of course.
Using nanomaterials into actually in nature, most of the things are already 3D printed. That is, all the surfaces, if you go with microscopy, electron microscopy, and atomic force microscopy, you will find some printing already done with sesame seeds. We have done some work on sesame seeds, and we have found that the surfaces are different in case of black sesame seeds and in case of white sesame seeds. They are already printed by nature, and you are doing that with to make the food more palatable.
Yes, so basically no man can match what nature offers. So nature is like so superior. It has all of its things. We're just trying to copy things from nature. So that's the logic. So how much time do I have, ma'am? Because there are lots of questions that I've just typed here. Do I have time or?
Two or 3 minutes you can have. Yeah,
okay,
you can
so
have
I'll quickly run along with the questions. Is there any nutritional loss? So there is no nutritional loss during the 3D printing process. But if you prefer for frying after the 3D printed, like you want fried butterfly shapes, or you want to have boiled butterfly shapes based on the process, then your nutritional value might change. Is it harmful for health? No, not at all. What about the sensory acceptance of 3D printed foods? In fact, people rate it better. Like, for example, millets. Everybody knows it's healthy, but a lot of people don't prefer eating millets because, they say, they don't like the taste. But actually, we all know it's good for health. So now can you make attractive millet-based products? Yes, we did it. And a lot of consumers showed exceedingly good preferences for that. What is the 3D printed food made of? It's just made of food. I mean, so the talk that I focus today is on food. There are lots of, metal can be printed, jewelry can be printed, a lot of those things can be printed. But today our focus was on food, how you can print food. So how you can work 3D food printing on probiotics. So basically the probiotic cultures are mixed with the material supply and then they are printed. So your printed material will have live cultures of the probiotic cells. And then thank you. Okay. I think, okay, can we take 3D printed foods into space? You should know that 3D printers go to space. Like, for example, if you have a defect in your, spacecraft, you just can't come back to land and then you can't, repair it. So what happens is these astronauts, they send the defect to the land, and people here send a particular coding, and that is printed in the 3D printer in the spacecraft, and the astronaut just takes the printed object and fixes it, repairs it. Now, you can also have a lot of space foods which are 3D printed because there's no issue of spoilage. You print it on spot. That minute I feel like eating something, I print it. Next minute I don't feel like eating the same thing, so I print a different one. So you can print it based on consumer requirement. And can 3D printed foods be used for some disease conditions? Yes, for example, diabetes. You want to reduce the sugar intake in a particular person's diet. 4 of them will get a particular diet. 5th person will get low sugar printed products. So you don't have to make a big formulation of the recipe like how you do it conventionally. You can use 3D printing technology to make it faster and more precisely. And nutritional standpoint, yes, they are very safe. Yes, we would be, shortly calling for, please stay in tune with our website, ifpt.edu.in. We will be calling for workshops very shortly. You're free to join. And yes, is it possible to print liquid foods? You can print liquids, solids, and semi-solids. So the task is to work on the rheological properties to make them printable. So if this is on extrusion printing, there are also powder bed printings and all where sugar crystals as such can be printed. So based on the printing method, different materials of foods can get printed. Thank you. Okay, I think okay, how a BSc microbiology student shift to nutrition is there? I think the organizers can better organize course related things. Is 3D medicine printing possible? Yes, it is already being done. Already there are tablets that are getting customized, personalized medications that are getting printed. You have also organs and a lot of biomedical applications from 3D printing. Are these molecules reusable? Basically, you're going to eat them. So that's the answer. Can you change any form of ingredients? Yes. In case the food is not getting printed, you should be doing a pre-processing using a hydrocolloid or something, improve the flowability of the material before you put it into the 3D printer for printing it. And is there any regulatory board controlling 3D printer? No, basically you're just trying to print the same food that you would otherwise do in another food processing operation. So, it's all the same ingredients. In case you want to add colors, it's all the same colors. In case you want to add flavors, it's all the same flavors. So, there is no unique, requirement for regulations as on date. I think I've answered all the questions. Ma'am, is that fine, or any other questions?
Thank you very much. And I will hand over to Amrita to thank Professor Moses
Thank you,
for a
sir.
wonderful and
Wonderful
very
session.
informative lecture.
So
Thank you.
informative, like an eye opener to us. So
Thank
thank
you
you
very
very
much.
much again. Now we will move on to our next session. Our next speaker for today is Professor Amol Kanti Bera. Professor Amol Kanti Bera has been working as a professor in the Department of Biotechnology, Indian Institute of Technology, Madras, since July 2015. Prior to joining IIT Madras as an assistant professor in 2005, he had been working as a research associate in UT Southwestern Medical Center at Dallas, Texas, and in Albert Einstein College of Medicine, New York, for years. Professor Bera has published 63 journal articles with 963 citations in the best scientific journals, along with his students and his collaborators. The majority of his research efforts are in the area of the study of ion channels associated with neuronal diseases, electrophysiology of ion channels, structure-function relationship and regulation of ion channels, and calcium signaling. Their long-term goal is to target specific ion channel for treating stroke, and heart diseases. We know that trans fatty acids are responsible to increase the risk of cardiovascular diseases by altering plasma lipid profile and activating various inflammatory signaling pathways. In 2016, Professor Bera published a research article where he had shown that ellagic acid, the most abundant trans fatty acid in diet, altered the electrophysiological properties of voltage dependent anion channel of mitochondria. We feel much delighted to receive Professor Bera and hear him on the topic entitled Trans Fat, a Silent Killer. Audience, you can put the questions related to the lecture in the chat box. Welcome, sir. The platform is eagerly waiting for you.
Thank you, Amrita. And first of all, I would like to thank Dr. Pubali for giving me a chance to talk about my work. So I will start presenting my topic. Is my slides are visible?
Yes, just put it on the slideshow.
Yeah, is it okay now?
Yes.
Yeah. Hello, everyone. I am Amol Bera from IIT Madras. So my lab is in Indian Institute of Technology, Madras. We are located inside a reserve forest, and all these animals you see, they all live in our campus. So these are all photographs taken from our campus. So it's a beautiful campus, and if you have some time, you can always come to our campus and visit. So today I'm going to talk about trans fat, a silent killer. All of you have heard about trans fat. We know that the trans fat is very bad for our health. Still, we don't care, or we really don't bother. We consume a lot of trans fats, and my work is, as Amrita told, we work mostly on different ion channels in my lab. So I wanted to see, or we wanted to see how these trans fat work in our body. We know that it produces lot of health hazards. It causes a lot of health hazards, like trans fats are the cause of one of the causes of diabetes and cardiovascular diseases, cancer, and so on. But we really don't know how they work in our system. So we are trying to understand the molecular and cellular mechanism of trans fat, how they work in our body. So these are the foods we all love. I love all these foods, you love, and I think most of us love this kind of food. These are so-called junk food, but really they are tasty, and we consume all the time. So as you know that these foods are not really good for health, because it has a lot of sugar, it has a lot of salts. Apart from that, it has a lot of saturated and trans fat. So trans fats I'm going to talk about. So what is different kind of fats we use? As you know that fat is nothing but the ester of glycerol and fatty acids. These fatty acids could be like saturated fatty acid. Saturated fatty acids means it doesn't have any double bond. On the other hand, unsaturated fatty acids have multiple or single double bond. If it has one double bond, it's called monounsaturated fatty acid, and then it can have multiple double bond as well. So when these fatty acids, actually, depending on the kind of fatty acids we have, the fats are designated as saturated, unsaturated, and trans fat, and so on. So what is trans fat? So these trans fats are, again, they are unsaturated fat. They have one or more double bond, but these fats are not produced in our body. We always, these fats are synthesized during different food processing, and we always consume it. We never produce inside our body. The problem is that once this trans fat goes inside our body, our enzyme is not designed to digest or metabolize this kind of fat, because enzymes cannot, whatever enzymes we have in our system, they don't recognize the cis, they recognize the cis double bond, but not the trans double bond. So you can see it here. Mono unsaturated fatty acid is oleic acid, one of the fatty acids. it has 18 carbon, and elayotic acid, which is the most common trans fatty acid present in our food, it has exactly same number of carbons, same number of double bonds, but the configuration of this double bond is different. This is called the trans, and for oleic acid, it is called the cis double bond. So this cis double bond can be broken by the enzymes, but not the trans double bond. So once trans fatty acids are in our system, it is very, very difficult to remove them from our system. They stay there for a long time, and as a result of that, it causes several diseases. Okay, so why this trans double bond is causing so much a problem? So you can see the geometry here. This trans, because of the trans double bond, once you have a double bond in your fatty acid, there is a kind of bending happens. So here it is, see, it is the bending. So this geometry is very important. But when a double bond is in the trans configuration, it is, the fatty acid is more or less, it looks straight. It is almost like a saturated fat. And as you know that saturated fats are not so good for our body, trans fat, because of this geometry of the double bond, cis double bond, they work like saturated fatty acid. Now, what are the known methods or known process by which these trans fatty acids are formed? So one of the main mechanisms by which these trans fatty acids are formed, this is hydrogenation of the oil. So during the hydrogenation, if the oil is partially hydrogenated, it forms a lot of trans fatty acids. So why, first of all, we need to hydrogenate the oil? The oil industry hydrogenate the oils because of many reasons. Once you hydrogenate the oil, they solidify. They decrease it decreases the rancidity of the oil and increases the half-life of the oil. So once you hydrogenate, the oil can stay much longer, and you don't need to refrigerate it. You can carry it easily, and it gives a better taste actually. Once you hydrogenate, these oils can be used for frying different foodstuff again and again, and it doesn't give you bad taste. In fact, it gives some desired texture and flavor. So that is the reason oil industry always hydrogenate the oil. And during this hydrogenation process, because of the partial hydrogenation, if the hydrogenation is not complete, then all these trans fatty acids are formed. So what are the known health risks? We know there are many experiments from which we came to know that cardiovascular diseases are the major diseases caused by the trans fatty acid. Because once you consume a lot of trans fatty acid containing food, it increases our LDL, it decreases our blood HDL, which is supposed to be the good cholesterol. And trans fatty acid consumption has been associated with the diabetes. As you know, India is the world's capital of cardiovascular disease and diabetes. So apart from genetic reason, now people think that because of our lifestyle, because of the food habit we are having, or we are getting so many cardiovascular disease patient and diabetes patient. One of the reasons is trans fatty acids. We don't care about the trans fatty acid. Obesity, it is already proven that if you consume a lot of trans fatty acid, it can cause you obese. Infertility, these are all known. Cognition, neurodegenerative disease. We speculate, or people believe, that trans fatty acid consumption is associated with cognitive decline of some people, and even it can cause neurodegeneration. It doesn't cause neurodegeneration. If you take a lot of trans fatty acids, it may help developing Parkinson's disease or Alzheimer's disease, but these are not yet proven. So why people think that trans fatty acid can affect your cognition, your learning and memory, or even it can cause or it can make you vulnerable to develop different neurological disease? There are certain reasons for that. First of all, trans fatty acid, if it is short enough, they can cross the blood-brain barrier. And once the cross the blood-brain barrier, they can reach your brain, and they can get incorporated into the membrane of your neuron and glial cells. And as I told you, that these trans fatty acids don't remove or get away from the system very easily, because they don't metabolize. So once they get into the membrane, they change the membrane property. And once the membrane property is changed, whether it is neuronal cell or other cells, it can cause all sorts of biological problems or signaling problems and so on. So what are the policies to eliminate trans fat? WHO recommended that foods should not have more than 2% TFA or trans fatty acid. And many countries already banned trans fat. Denmark, for example, in 2003, they made the law that all foods, no matter what food it is, whether it is oil, fat, or food products, shouldn't have more than 2% trans fatty acid, 2% of total fat. In Canada and US, they banned the use of partially hydrogenated oils, and it is mandatory there to label the food. What percent of trans fatty acids present in the food, it's mandatory to mention that. In Singapore, also the limit of trans fatty acid in foods, including oil and fats, it is 2%. And what about India? Okay, in 2017, India implemented a mandatory limit of 5% trans fat contents in fats and oils, which is more than double what WHO recommend. But the point is, this 5% limit is in fats and oils. It doesn't say what is the limit in different foods. People can have even more than 5% trans fat in food if you use different kind of oils. So that is a really bad thing. But the good thing is that India's apex food regulator made a draft in September 2009 to limit trans fat in food product to 2% through an amendment. And we hope that this will be implemented very soon. It's a really good news. Okay, so in my lab, we're trying to understand that we know trans fat causes several diseases. It can cause heart disease, it can cause diabetes, it can cause obesity. But at the molecular level and cellular level, how it works, why people get heart disease if they consume a lot of trans fat. So what is known? It is known that if you increase consumption of trans fat, it increases the expression of your inflammatory genes. It produces a lot of ROS. It also causes metabolic remodeling. So your all metabolic pathways basically get altered because of the consumption of trans fat. I will be talking about one trans fatty acid, which is called eleidic acid, because eleidic acid is the most abundant trans fatty acid present in food. But why do we work on? Western countries stopped working on trans fat because they banned it. They don't use trans fat, so they don't care. In India, if we implement that 2% is the maximum limit of trans fat use, and as you know how things work in India, people don't care. There are rules, there is no implementation. And think about you are having some jalebi or samosa from roadside. You don't know what oil they're using. They don't really care whether 5% trans fat is there or 10% trans fat is there. By the way, people use dalda or banaspati, which has about 12% trans fat. So in India, no matter whatever rule you make, it's very, very difficult to implement. So we are trying to understand or trying to find out from some antidote. People will eat trans fat containing food, but what is the antidote? So if you know the mechanism, how this trans fat works in our system, it would be easy to treat, or it would be easy to find out what is the antidote. So our aim is to find out in our lab, we are trying to understand how this trans fatty acid works in our body. As you know that all cells, basically all human cells or plants have cell membrane. The cell membrane is made up of mostly lipid. It's called lipid bilayer. So I think a lot of students are there, so I will discuss a little bit of basics. So it would be easy for you to understand. So these lipid bilayers are not very rigid. They are mobile. That's why we call it fluid mosaic model. So the fluidity of the lipid bilayer is very, very important. As you know that different proteins are embedded in the lipid. So these proteins are transporters, these proteins are receptor, these proteins are different ion channels. So the activity of these proteins can be dictated or can be regulated by the physical properties of the membrane. If you have more trans fatty acid or saturated fatty acid in your membrane, it changes the properties. And if it changes the properties, the receptors and proteins which are embedded in the membrane, their activity is going to be altered. So we hypothesize that the basis for all this disease caused by trans fatty acid is the change in the membrane properties. So what happens if you have saturated fatty, a lot of saturated fats in your membrane? So saturated fats, because of their structure, they can, if they don't have any double bond, so they can pack very tightly. So if they pack very tightly, the fluidity of the membrane actually changes. It becomes less fluid. But the fluidity is required. Proper fluidity of the membrane is required for signal transduction, for the proper functioning of the proteins which are embedded in the lipid bilayer. Now, if you have unsaturated fatty acid, because of this double bond, as I told you that once you have a double bond, it gives some sort of kink. So if you have double bond, fatty acid or fats cannot be packed very tightly. So it gives some fluidity. And also the lateral base pressure, these lipids are moving, and proteins are also moving in laterally, they move. Okay, mostly they move laterally. Now these fatty acids, they are going to apply some lateral pressure. So that lateral pressure would be different if you have a lot of saturated fatty acid and if you have some sort of fluid membrane. Okay, so two changes is going to happen if you change the lipid composition of or nature of the lipid which is present in the membrane. One is membrane fluidity and another is lateral pressure exerted by these lipids. So we think this is the basis for the molecular basis of trans fatty acid action. So first of all, we want to see, if you treat the cells with trans fatty acid, what happens? Where does this trans fatty acid go? So what we did here, we isolated the membrane after treating the cells with ileidic acid and oleic acid. Interestingly, what you see here, that ileidic acid, which is the trans fatty, as well as oleic acid, they get incorporated into the membrane. So once you consume a lot of trans fatty acid, no matter what is the source, some of the trans fatty acid is going to be incorporated into your membrane. Not only that, naturally, we have some oleic acid in the membrane. So these trans fatty acids replace the oleic acid. So oleic acid, which is a cis monounsaturated fatty acid, that is now replaced by the trans fatty acid. So it is going to make your membrane less fluid and more rigid if you take a lot of trans fatty acids, or if you consume a lot of trans fat. So we are interested to know about Parkinson's disease. So we know that nowadays our Parkinson's disease as well as neurological functions. Nowadays, you know that our kids are taking Maggie, pasta, all sorts of junk food all the time. We always wonder, are they going to affect their learning and memory? Are these kids, or even we eat a lot of trans fat in our old age, are we going to develop Parkinson's disease or Alzheimer's disease because of our trans fat content in our diet? So to answer that question, we started working on Parkinson's disease, how trans fatty acid actually, whether it makes us, or if you consume a lot of trans fatty acids, is it going to cause developing these neurological disorders like Parkinson's and Alzheimer's disease? So what is the reason for believing that? As I told you, that trans fatty acid can cross the blood-brain barrier and it can reach brain easily. So once they reach brain, they can be incorporated in the glial cell membrane as well as neuronal membrane. As I told you before, that once they incorporated into the membrane, it is going to change the neuronal properties as well as function. So on the basis of that, we started working on Parkinson's disease. So I'll be talking about one protein which is called alpha-synuclein, which is associated with Parkinson's disease. You know that Parkinson's disease is due to the degeneration of our dopaminergic neuron present in the substantia nigra. So dopaminergic neuron gets degenerated because of many reasons. One of the reasons is alpha-synuclein. So alpha-synuclein is a small protein. It is called intrinsically disordered protein. So this protein is essential protein for our for release of neurotransmitter, vesicle fusion, vesicle transport, and so on. But when this protein get misfolded, they aggregate. Those aggregates are toxic. Those aggregate, once they are deposited on the neuron or glial cells, they kill the neurons. So how they kill the neurons, or that is the basis for, one of the basis for developing Parkinson's disease, aggregated alpha-synuclein. So we don't know exactly how aggregated alpha-synuclein actually kills our neuron. One of the theory is that this aggregated alpha-synuclein forms the channel on the neuronal membrane as well as glial membrane. So once they form the channel, the neuron is going to die. because these channels are originally not present in the neuron. You are additionally making some pores on the membrane, so that cause the glial cells and neuron to die. But that is one of the theories. That is not the only theory for developing Parkinson's disease. So we started working on alpha-synuclein. So basically, we want to study if you have trans fatty acid in your system, how this alpha-synuclein behaves, and if you have oleic acid, which is the monounsaturated cis fatty acid, how this alpha-synuclein behaves. So as you can see it here, that these are the atomic force microscopic picture of aggregated alpha-synuclein. You can see that it is forming channel on the membrane. So what we did, we took the alpha-synuclein clone, human alpha-synuclein clone, and expressed in E. coli. After expressing in E. coli, we purified the protein, we oligomerized them. If you put the alpha-synuclein for some time in the lab at 37 degrees, they oligomerize. So those oligomerized protein, what we did next time, we make a lipid bilayer, synthetic lipid bilayer we make, made up of different kind of lipids, and then we put those alpha-synuclein inside these lipid bilayers. So once these alpha-synuclein get incorporated into the bilayer, it forms the channel. And you can monitor the activity of this channel by putting a voltage. Once you put the voltage, the ions will flow through these channels and you will get a current. So basically, you measure the activity of these alpha-synuclein channels by measuring the current. So you purify it, incorporate it into lipid bilayer, and then study their properties. Now we make the lipid bilayer. One lipid bilayer which has phospholipid along with elaidic acid, and another lipid bilayer which has phospholipid along with oleic acid. Oleic acid is the control. Interestingly, what we found that in presence of elaidic acid, these alpha-synuclein proteins, aggregated alpha-synuclein proteins, are forming bigger channel, much wider channel. Not only that, they are keeping open for, they are remaining open for longer time. So you can think that these channels are not, they are not present originally in the neuron. Once you have more trans fatty acid in your membrane, alpha-synuclein can form larger channel. That means it is going to kill neuron more than what they do if oleic acid is there or other unsaturated cis fatty acids are there. Or in other words, alpha-synuclein channel becoming more toxic in presence of elaidic acid. So as you know that Parkinson's disease is associated with mitochondrial dysfunction. Mitochondrial dysfunction is the cause. Some people believe that mitochondrial dysfunction is probably the main cause for developing not only Parkinson's disease as well as Alzheimer's disease also. So what happens in Parkinson's disease, mitochondria, it produces lot of more calcium, and not produces calcium, I would say calcium homeostasis get interrupted during Parkinson's disease, and mitochondria play a big role in cellular calcium homeostasis. It produces a lot of reactive oxygen species and so on. So basically all mitochondrial functions get disturbed or altered during Parkinson's disease. So we thought that, okay, let's see if that is the case, if the mitochondrial dysfunction is the cause or basis for Parkinson's disease, how elaidic acid is affecting mitochondrial dysfunction or mitochondrial function. Is it going to affect mitochondrial function or not? So we wanted to study that. So for that, what we first did, we took a channel protein which is present in the outer membrane of the mitochondria, which is called the voltage dependent anion channel. As you know that mitochondria has two membranes. The outer membrane is quite permeable. So small molecules, even some bigger molecule, can easily go through the outer membrane. But inner membrane is highly selective. They don't allow each and every molecule to go in and out. So the high permeability of the outer membrane of mitochondria is caused by the channel forming protein called VDAC. So this VDAC protein is the major protein in outer mitochondrial membrane. So this VDAC protein is responsible for the flux of ATP and ADP across outer membrane. Not only ATP, different metabolites, small molecule can easily go through this outer membrane through this VDAC channel. Now, why this VDAC channel is important? VDAC channel interacts apart from forming this channel, this VDAC channel is associated with many pro-apoptotic and anti-apoptotic proteins. So they regulate the cellular cell survival and death. So if there is a problem in the VDAC channel, you might have some diseases. And people already showed that VDAC channel activity is affected during Parkinson's disease. So what we did here, we tried to see how this trans fatty acid affect the function of VDAC, whether they affect or not. So like previous alpha-synuclein, here what we did, we purified this VDAC protein from rat brain and then incorporated it in lipid bilayer again. Now this lipid bilayer, we can manipulate the composition of the lipid. So once we made lipid bilayer where we have ellagic acid, and again we make the lipid bilayer where we have oleic acid. Oleic acid is the cis trans fatty acid, and that is the control. So now we compare the activity of VDAC. So what we interestingly we found that like alpha-synuclein, VDAC is forming much bigger channel in presence of ellagic acid. Not only that, here also these channels are remaining open for much longer time, which is not desirable. So if that's what happened, mitochondrial dysfunction is going to happen. So so far what I told you that because of their insertion in the membrane, ellagic acid or trans fatty acids are affecting the function of different channels like alpha-synuclein channels, which is associated with Parkinson's disease, and VDAC channel, which is associated with regular function of mitochondria. So once you have more, or in other words, if you consume a lot of trans fatty acid, it's going to affect your mitochondrial function. Definitely it's going to affect the mitochondrial function. Another point I want to make it that if you take more trans fatty acid, the uptake of cis fatty acid is compromised. So your body needs, your cells require cis fatty acid, because cis fatty acids, once whatever fat you get or whatever fat you consume, the cis fatty acid is taken up by the cells and it is oxidized to produce energy. Now, if you have trans fatty acid, if you consume more trans fatty acid, the uptake of cis fatty acid is compromised. So your system is now energy compromised. That energy compromised system is also one of the cause for developing Parkinson's disease. So it is not, we can extrapolate our results to say that there is a possibility, high possibility that if you consume a lot of trans fatty acid, you might develop Parkinson's disease or Alzheimer's disease in your old age. Now, as I told you that in the membrane, we have a lot of channels, we have a lot of transporters, and we have different receptors. Those receptors are associated with cell signaling process. Now, as you know that calcium homeostasis or calcium signaling is a very important signaling process in our system. Any disease, you name any disease or any physiological process, some way or other, calcium is associated with that. So calcium homeostasis, maintaining the calcium homeostasis is very, very important for our system. Now we want to see whether trans fatty acid dysregulate the cellular calcium homeostasis or not. Now to start with, I'll give a brief idea about, or I'll tell a little bit about calcium signaling. So calcium is an essential part of our life. It's a life and death signal. Our life starts with fertilization. The moment sperm fertilize the egg, immediately there is a rise of calcium inside the cell. And that rise actually spreads from one corner of the cell to the other corner, like a wave. So this propagation of calcium wave is very, very important, not only for fertilization, for almost all biochemical, biophysical processes. This pattern of calcium wave, how the calcium wave is propagating, the pattern of calcium wave, how much calcium is increasing, those things determine what kind of gene will be expressed. Okay. For your normal function, this calcium signaling, that's why it's so important. Now, concentration of the calcium inside the cell is highly regulated. Inside the cell, in the cytoplasm, the calcium level is maintained somewhere at the nanomolar level. Outside, it is millimolar. On top of that, we have a lot of calcium stores inside the cell. Those stores are endoplasmic reticulum, mitochondria. They can store a lot of calcium. So now, if you consider the cell death process, which is associated with almost all disease, in death process, no matter whether it is apoptosis, whether it is necrosis, always there is a calcium component. If your cellular calcium goes beyond certain level, more than micromolar, the cells is going to die. And that's what happens in most of the disease process. So you wanted to see how the calcium signaling process is affected if you have a lot of trans fatty acid in your system. So let's talk about a little bit about the different players in calcium signaling pathways. So cellular, as I told you that which brings calcium inside the cell. Like in neuron, we have NMD receptor, which when they gets activated, calcium comes in. We have TRPC channel, we have calcium. In mitochondria, outer membrane, as I told you that VDAC is there. In outer membrane, there are channels which allows calcium to go in. But inner membrane, there are transporters, which inner mitochondrial membrane, which is called mitochondrial calcium uniporter. They bring calcium inside the mitochondria. Now, ER also release calcium. It can take up calcium and it can release calcium. And there is a crosstalk between ER and mitochondria. So this crosstalk happens through the exchange of calcium. So once calcium comes in, calcium level inside the cell goes up, and cells doesn't want calcium to be stay high for longer time. So what they do, they immediately efflux some calcium outside by using a protein called PMCA, and then some calcium is taken up by the mitochondria, some calcium is taken up by the ER. That's the way the calcium consumption goes down. Now, when cells don't have much calcium, or when the receptor, particular G protein coupled receptor, once they get activated, they produces IP3, and IP3 activates IP3 receptor present in the endoplasmic reticulum. Once these IP3 receptors are activated, they release calcium. So calcium comes out from ER, goes to the cytoplasm, and immediately it is taken up by the mitochondria to some extent, and it goes out of mitochondria. So this network or this signaling is maintained throughout the organisms. Different organisms has exactly almost similar mechanism, and it is very, very important to maintain this interaction of these different receptors and channel to maintain the level of calcium. So we try to understand what is the calcium signaling happens, or whether the calcium signaling is altered when you have a lot of trans fatty acid. So what we did here, we measured the calcium inside the cell. We trigger, I told you that if you activate GPCR, one kind of GPCR, there is a rise of calcium. So we measured the intracellular calcium in real time. So we activated the cells by using a muscarinic receptor agonist called carbachol. So once you activate the cells with carbachol, cells will produce IP3 and release calcium from endoplasmic reticulum. And you measure that endoplasmic, how much calcium comes out from the endoplasmic reticulum to cytoplasm by using a dye called Fura. So what do you see that if you treat the cell with ellagic acid versus oleic acid as a control, you see that ellagic acid treated cells are releasing more calcium from ER. The cytosolic calcium is becoming increasing more in comparison to oleic acid treated cells. Now, from where this calcium is coming? Is it coming from ER? Why ER is releasing more calcium, or ER has more calcium in ellagic acid treated cell? To understand this problem, what we did, we directly injected IP3 inside the cell. So instead of activating the receptor and then producing IP3, what we did, we directly injected IP3 in the cells. What you see that there is an immediately rise of calcium, and again here the calcium rise is much higher in ellagic acid treated cells in comparison to the oleic acid treated cell, which means that ER has more capacity to release calcium once you treat the cells with IP3, or once you treat the cells with ellagic acid. Why is it so? One possibility is that it is once you treat the cells with ellagic acid, they are synthesizing more IP3 receptor. To prove that, what we did a simple semi-quantitative PCR, and what we found here that amount of IP3 receptor in ellagic acid treated cell is much more than oleic acid treated cells. So it suggests that it tells you that the ellagic acid treated cells, they have a disturbed calcium homeostasis mechanism or dysregulated calcium homeostasis. Now I'll tell you the crosstalk between endoplasmic reticulum and mitochondria. As I told you that endoplasmic reticulum release calcium. Once they are activated by IP3 receptor release calcium, and that calcium takes up immediately by mitochondria. There is a physical interaction between endoplasmic reticulum and mitochondria and endoplasmic reticulum. There are certain regions in the mitochondria and ER where they come very close and interact with each other to different proteins. This is called mitochondria associated membrane. This is a microdomain where calcium concentration is very high. And this interaction is absolutely necessary for proper working of the cells as well as functioning of mitochondria. And it is interesting that in Parkinson's disease particularly, this interaction, the crosstalk between IP3 receptor and mitochondria gets affected. So you wanted to see how this interaction happens when if you have ellagic acid in your system. So basically what we did, first of all, we wanted to check whether ellagic acid is going to the mitochondrial membrane or not. Yes, if you treat the cells with ellagic acid, some of the ellagic acid is getting incorporated into the mitochondrial membrane. Next, what we did, we measured the mitochondrial calcium uptake in real time. Okay, so what we did here, we expressed a genetically encoded protein called inverse pericam. It's a fluorescent protein. This protein specifically goes to mitochondria, and this is a calcium sensitive protein. The moment calcium in mitochondria increases, the fluorescence decreases. So you can measure by transfecting the cells or expressing the inverse pericam in the cells, you can measure the mitochondrial calcium uptake in real time. So what we did here, we activated IP3 receptor and then measure the calcium uptake in the mitochondria. So fluorescence, the more calcium it goes in, the fluorescence decreases. So the moment you activate IP3 receptor, ER release calcium and that is taken up by the mitochondria, you can see that. But mitochondria has the capacity to actually remove this calcium immediately. So there are two ways it buffers the calcium. It has enormous capacity of increasing, buffering the calcium inside the matrix. So some of the calciums which comes from ER, it gets buffered and some of the calcium goes out. Okay, so this part is going back, that means the calcium is going out. So that's what happens in oleic acid treated cells. And in normal cells, if you don't treat the cells with oleic acid also, you see this pattern that you activate, calcium is released from ER, it goes into the mitochondria, and then mitochondria release back the calcium and buffer to some extent. But interestingly, what we found here, ellagic acid treated cells, they take up mitochondria takes up calcium, but calcium remains very high inside mitochondria. It doesn't get buffer or it doesn't go out. So mitochondrial matrix calcium level is increasing enormously high once the calcium signaling is triggered, which is not really good, because if you have a high level of mitochondrial calcium, it can trigger formation of reactive oxygen species, it can trigger the apoptosis and so on. I'm coming to that point. So we wonder why is happening, what ellagic acid is doing that mitochondria is taking up calcium but it is not releasing. So what we found that once you treat the cells with ellagic acid, they are a protein called NCLX. NCLX is the protein which is present in the inner mitochondrial membrane. It is responsible for the efflux of calcium from matrix to outside. So like VDAC brings the calcium in from through the outer membrane, then unipoters are there that brings the calcium into the matrix, and from the matrix calcium goes out by this NCLX protein. So what we see that NCLX protein expression level is compromised. So there is no NCLX protein or less NCLX protein in ellagic acid treated cells. That means mitochondria, that is the reason it is taking up calcium, but it is not removing the calcium from the system. Calcium is staying there for longer time. And what is going to happen? So if you increase the mitochondrial calcium level and stay high for longer time, then it induces apoptosis. The mitochondrial potential, the mitochondria inside the mitochondrial matrix is highly negatively charged. So mitochondrial potential is going to collapse and mitochondria is going to produce a lot of loss. That's what happened. What we see here that, okay, normally if you treat the cells with ellagic acid and if you take the measure the mitochondrial potential or ROS, it doesn't look any different. Oleic acid treated cell and ellagic acid treated cell, they look all the same. But if you expose them to some stress, like here we give the ischemia and reperfusion. If you give ischemia, then mitochondrial membrane potential collapse. We know that. But this collapse is much higher where you have cells treated with ellagic acid. Similarly, ellagic acid treated cells are producing more ROS. We measure the ROS inside mitochondria by a dye called mitosox red. So what we see here that ileic acid treated cells are producing more ROS, and mitochondrial potential is collapsing more in ileic acid treated cells. These are all an indication that these cells are going to, mitochondria is defective now. If mitochondria is defective, as you know that it will not produce ATP properly. Not only that, it induces apoptosis. How it will induce apoptosis? This ROS and high calcium together, they trigger a phenomena which is called permeability transition pore opening. So there are big channels in the membrane which are in the mitochondrial membrane which are not open in normal circumstances. But when you have this high ROS and high calcium, this transition pore opens, cytochrome C released from mitochondria to cytoplasm, and that cytochrome C activates many cascades and triggers the apoptotic process. And this is one of the mechanisms of many disease, underlying mechanisms of many diseases. You will see in many diseases mitochondria is defective. So this is the way it is happening. So all this tells you, and then next what he did, okay, let's take cells and treat with ileic acid, uric acid, and see whether their survival. If you put them under ischemia and reperfusion, you see that ileic acid treated cells are dying more in comparison to the uric acid treated cells. So all these indications tells you that ileic acid is actually causing your cell death, is causing the mitochondrial dysfunction, it is changing the activities of many channels, it is actually dysregulating your signaling process. These are probably the basis for developing different diseases like Parkinson's and Alzheimer. To summarize what I told you, that ileic acid gets incorporated into cell and organelle membranes, changes the properties of different ion channels and transporters. Aggregated alpha-synuclein, which is a causative agent of Parkinson's disease, forms larger channel in the synthetic membrane in presence of ileic acid. Ileic acid changes the properties of VDAC. It forms larger channel. Ileic acid alters cellular calcium homeostasis, affect mitochondrial calcium efflux, and so on. It produces more loss. All these factors contributing to the onset of different disease, and it is contributing to the onset and progression of different diseases like Alzheimer's, diabetes, cardiovascular disease, and so on. By the way, we looked at some cardiac channels. We know that it causes, ileic acid causes heart disease. It is already known. Trans fat, if you take a lot of trans fat, you are going to have a lot of heart problems. And why these heart problems happen? We found that there is a channel called HARG channel in potassium, potassium channel in heart. Those channel activities is compromised if you take a lot of trans fat. So these are the lab members. The VDAC work was done by Debanjan, who was a PhD student that time, and he's now doing postdoc in Washington University, I guess. And then Sucheta did the alpha-synuclein work, who was a MS student in my lab. Now she's a PhD student in Switzerland. Dhriti was a postdoc who did all this calcium signaling part. I think Dhriti is listening to the talk. And these are the other people, are the current member, and they are associated with different projects. And collaborator, I have strong collaboration with my friend and Dr. Prosun Nayak, who did some animal experiments. So what he did, basically, he fed the animals with ileic acid and oleic acid and see how these animals behave, rat. So interestingly, or not interestingly, after treating them, giving them 1 month, when we took their blood, we don't see any change. So the mice, I think he worked with rat, on rat. So rat was given ileic acid and oleic acid. And after 1 month, when we took the blood and analyzed the lipid profile, glucose, everything looks perfect. Mouse and rats looks perfectly happy. There's absolutely no neurological problems and so on. And then we stopped that work. But we know now that why we didn't see the effect. We gave them ileic acid. We don't eat ileic acid as such. We take trans fat or fat. So and also the duration, how long you are treating the animal, that also matters. So we are going to revive this project again. And funding, people don't like, funding agency don't like, they are happy with trans fatty acid containing food, they like samosa and so on. So my project is not funded, but Dhriti got this project. Actually, Dhriti's project was funded by ACRB. She was a national postdoc, it's called national postdoc, NPTF. Yes, in my lab now she is working with companies. That's all, and thank you for listening my talk.
Thank you very much, Professor Bera, for a wonderful, for a new area, how neurobiology can be connected to nutrition. And we always talk about that trans fats are very bad and we should not, but it is working at the level, at the molecular level in neurons and in the mitochondria of those neurons, causing permanent damage. So it's a very high level work. I understood what I understood, and the relationship between these channels, the calcium channels, with this VDAC, along with with trans fats. So from your talk, I think that the different fatty acids, they will also have these types of, we can add a new area, how different fatty acids, they can change the membrane structure of the neurons and the mitochondrial membranes and the Ross generation. I think that will be another area. Is it already done?
To some extent it is done, Kubali. Yeah, you are right. So if you actually we did with saturated fatty acid, if you incorporated a lot of saturated fatty acids, you will see the similar effect. It is happening. And people mostly studied biophysical, how these fatty acids change the membrane properties and so on. And not much study were done on signaling process or biological aspects. People mostly looked at the physical properties of the membrane, how it gets affected if you increase cholesterol or lipids and so on. So this is a nice area. In fact, yeah, I see a lot
And
of things.
each of the fatty acids, they have different structures. Each of the polyunsaturated fatty acids with eicosapentaenoic acid, as you have told that the trans fats, they are straight in nature and similar to saturated fats. But when you are adding unsaturations, they become very
Yes,
curvy in nature,
yes,
and
yes,
that will affect more. I think that will affect more,
yes,
but less effect, or they may have a good effect, I think.
yes, yes, exactly.
Polyunsaturated fatty acids.
See, the main problem is that trans fatty acid, they are staying there almost permanently. They don't, trans
Okay.
double bond don't get don't get uh, broken, because enzymes not able to break the trans double bond. So that is another. So you takes a lot of saturated fatty acids. Ultimately, it will be removed. It will be removed from your system. But trans fats, they stay there for longer time. That is the probably one of the causes of this disease. Yeah,
Krishnendu, I'm taking Krishnendu's question. Krishnendu said physiology, from the physiology background, as your lecture is very much related to physiology. I have one question: is there any role of ellagic acid induced inflammasome activation in neurodegenerative disease, or is there any involvement in P2X7 receptor? I don't know about this
yes,
receptor.
yes, Krishnendu, yeah, you are right. Yeah, it is. People didn't really study that well. The reason I told you that, US stopped studying it because they don't need to study. They stopped trans fat use. So whatever study is happening in only few countries, because nobody or most people better thought of, let's ban the trans fat. Now there are a lot of reports that trans fat that increase the expression of inflammatory genes associated with inflammation. But your specific questions, I have not seen any report on that. But I am sure it is doing that. It is doing that, and it is, that this is one of the causes of neurodegenerative diseases. So definitely it is doing that.
So Debanjana is working on neurodegenerative disease, and she's saying that, can you please explain how VDAC and neurodegenerative diseases are interlinked?
Okay, so VDAC is a channel which is present in the outer mitochondrial membrane. So what it does, it actually allows your ATP, which is produced inside the mitochondria, it goes out through VDAC, and ADP comes in through VDAC. Not only ADP, other metabolites also cross outer mitochondrial membrane through this VDAC. Apart from that, VDAC interacts with many apoptotic and pro-apoptotic as well as anti-apoptotic proteins like BCL2, BAX, and so on. So there is a network. Once this VDAC activity is compromised, either because of mutation or there are drugs for targeting VDAC, so the entire network gets affected. Mitochondrial calcium homeostasis get affected, and these are the fundamental reasons for developing any disease per se, not only neurological disorder, any disease. So you will see that mitochondria is affected. So that's why VDAC is not directly contributing to the disease, but because VDAC is associated with many other proteins and itself is associated with calcium homeostasis, VDAC, any problem in VDAC can cause neurodegenerative diseases. Am I clear?
Yes, yes. Thank you, Professor Bera. Now it's Amrita to introduce our next speaker. She is already here. Oh.
Thank you, sir, for this amazing lecture. We will move on to the next session and the final session. Our next speaker for today is Professor Madhumita Dobe. Professor Madhumita Dobe has several accolades and accomplishments that are quite impossible to sum up in such a brief time, yet I am trying my best. Professor Dobe is currently working as Director Professor of Public Health at All India Institute of Hygiene and Public Health, Calcutta. She has been the former Dean and Head of the Department of Health Promotion and Education in the same institute. Professor Dobe has several publications to her credit, including articles, commentaries, and editorials in peer-reviewed journals and contribution of chapters in books and monographs. Her special interest lies in health promotion, social determinants of health, social and behavioral change communication, health education, social research, maternal and child health, and nutrition. She has been contributing herself as National Coordinator Multicentric Studies on Community Behavior regarding Malaria Prevention and Control ICMR, member of Advisory Board of the World Federation of Public Health Associations, member of the International Expert Group in Health Promotion at WHO HQ Geneva, and so on. She was a reviewer or referee for the JPHP, JIDA, JIMA, Applied Nutrition and Indian Journal of Public Health, as well as the organizing secretary of 14th World Public Health Congress 2015. It's an immeasurable contentment for us to hear Professor Dobe on the topic entitled Looking Beyond Food to Improve the Nutrition Scenario. The chat box is open for question answer session. Welcome, madam. This is the moment that we have been waiting for. Please share your lecture with us.
Good evening, and thank you very much for having me with you here today. As I was listening to Professor Bera's very erudite deliberation, I was actually thinking that it is a vast leap which I have to now take from your laboratories down to the field. Because I'm from public health background, so translating all the wonderful research that you have done in terms which would be actually implemented or understood by the common person. This is the great and very daunting job which we have to face. So my today's presentation would be, we talk about nutrition, we talk about food, but there is much beyond that. And I would like to share with you some of these thoughts over the next few minutes so that it generates more debate, perhaps generates more research and more insights and understanding into how we can go about doing things in a country like ours, not only now that we are facing a huge barrier of this pandemic, but also later on when hopefully all this subsides. So just give me a minute to go to the presentation. Is this visible? Is this visible?
Yes, madam, it is visible.
Okay, okay, thank you. So what I thought is to ignite your wonderful brains to some thoughts on looking beyond food to improve the nutrition scenario which actually ails the country today. And this will be more like deliberations, not really looking into very many facts and figures, but yes, behind every fact there is a story, and I'd like to share some of that with you. This is the National Nutrition Month. We have weeks, we have months, and the very purpose of these having these special months or weeks is that we would like people to sit up and think what is ailing us, what is really not happening, which should have happened with such wonderful brains all around, with such a lot of research going around. Where are we failing? So this involves a lot of advocacy, a lot of talk, discussions, so that we can come out with solutions or perhaps suggestions so that the country moves in the way it is required to do. For that, let's first look at what is nutrition then. Nutrition is not only food, it is the science of food. And basically, why do we talk so much about nutrition and why are we concerned so much about nutrition? It is because of its relationship with health and well-being. If we are not having proper nutrition, we cannot be well. All your brains that are functioning wonderfully are all because of basically your cognitive development, which depends upon nutrition. So adequate nutrition is very essential for human development. And not only, this is not a phasic thing in one period of life. It is essential from the very early stages of life, right throughout life, for growth, development, and later on also for well-being. But we equate it with only supply of proper food, but that is not enough. How and why? Let's have a look into what is happening. We talk about malnutrition, and if you go into, you are much more savvy than I am in this, all the students who are here, all the researchers who are here. If you go into the internet and the publications, you would find that this country has embarrassing statistics of malnutrition, both undernutrition and overnutrition. By undernutrition, we have certain indicators by which we determine whether the population is suffering from undernutrition. And the two major indicators are stunting, which means that children particularly have low height for their age, which is an indicator of chronic undernutrition, and wasting, which is measured by low weight for height, which again is more reflective of acute undernutrition. Like during this corona period, we are reading reports of children being, particularly the vulnerable, the risky children, children of migrant laborers who've lost their jobs, who had to go back to their places, who've been forced into labor, once again, child labor, or being married away. So these children would be suffering from wasting more. Underweight is something which happens at the primary end of the spectrum when you just start losing weight. That is low weight for age, but not so low that it can be characterized as wasting. And besides that, now what is also being felt as a huge problem is the micronutrient deficiencies. By macronutrients, it's something which can be seen. It's the seen hunger. You can either see it, people getting food or not getting food. But the hidden hunger comes from the micronutrient deficiencies, the so vital minerals and vitamins, particularly iodine, particularly iron, which is actually the huge problem throughout the country. These cannot be seen because when we see anemia, that is at the end of the spectrum. Things start happening much before that. Then we'll come more in details. The second problem which we are also facing nowadays is overnutrition, which is indicated by overweight and obesity. Now, coming back again to stunting, the child, as I said, is too short for his or her age. These children can suffer. Why we are so concerned about stunting is that it happens at one phase of life, but the effects of stunting stay throughout life. They suffer severe, irreversible physical damage. Not only that, you remain a short individual, and cognitive damage. So that even if you're given chances later on, this gap cannot be overcome. These devastating effects, they last a lifetime. And not only that, they will also affect the next generation, particularly if women suffer from stunting. Wasting. The child is too thin for his or her height. And as I said, it is the result of recent rapid weight loss or failure to gain weight. It happens in disasters, and this pandemic is a disaster of unforeseen magnitude. A child who is moderately or severely wasted has an increased risk of death. You are also aware of those who are into the applied field of severe acute malnutrition. Such a thing should not be happening at all, because there are many programs which should look at it as a screening mechanism. But unfortunately, it still plagues this country. But here, the good thing is that still you can treat, you can rehabilitate. So we do have some programs for that. Overweight refers to a child who is too heavy for his or her height. This results from energy intakes from food and beverages that exceed the child's energy requirements. What it is burning, it's taking in much more than that. Not only taking in much more, taking the wrong type of food. Just now, Professor Bera has given a wonderful deliberation on trans fats. So whatever these rapid or fast foods have is very highly loaded with these fats. And that leads to the increased risk of diet-related non-communicable diseases later on in life. So if we look at this poster here, we now know that the development of a country is measured by many nutritional indicators. And the Millennium Development Goals, which have now been replaced by the Sustainable Development Goals, if you're aware, SDG, and we are all starting to push it back. The achievement is being pushed back, but still by 2030, our goal, one of the major goals, goal 2 of SDGs is zero hunger, which means the whole world aims to end hunger. We aim to achieve food security and improve nutrition, along with promotion of sustainable agriculture. Why we are thinking in these terms, we'll just discuss. In this world, 821 million, that is 1 in 9 people are undernourished. This is not a problem of our country alone, it happens in other countries as well. But we are very high up in the rung. 277.2 million are undernourished only in South Asia. In India, if we see, 3 in 10 stunted children are Indian, which means we are contributing to 1/3 of the total stunting burden in the world. 53% of women between 15 to 49 years, the reproductive age group, are anemic. So hidden hunger or micronutrient deficiencies are again rampant. And over 80% of infant and young children do not get minimum dietary diversity. We'll come to dietary diversity in a while, and I'll elaborate later. We need to also keep at the back of our mind 2 more facts. One is that still over 40% of the total Indian workforce is employed in the agricultural sector. Why that is important in terms of nutrition, especially sustained nutrition, we'll come to it. And if we think of the consequences, that the rate at which we are going with the economy falling, if global food prices double, India will lose up to $49 billion in GDP, and that will also reflect on your research, I'm sure. This is not something new. This revelation is not new. In the year 2012, while releasing Hangama Report 2011, that's Hunger and Malnutrition, a separate report was brought out by Dr. Manmohan Singh, the then Prime Minister of India. And he, being the economist, he expressed dismay at the unacceptably high levels of malnutrition, despite we were having a very high and impressive GDP growth at that time. So that's what we need to look into. Nutrition is not always due to lack of money. Even when we had good GDP growth, we were not having similar growth in nutrition levels or improvements in nutrition levels. So this is our national shame, I suppose. So if you look at the pattern of stunting prevalence among Indian districts, this was a study by Menon in 2018, you can see that obviously the dark orange ones are with very high prevalence, more than 40%, the high prevalence being 30 to 40%. If you look at Bengal, we have areas with low prevalence, we have those with medium prevalence, but as we go towards the north, especially the tea gardens contribute to this, we do have a lot of chronic undernutrition happening. And if you look at the overall map, you will find that there are the vulnerable and the risky populations in almost every state who are bearing the brunt of stunting. So these SDG goals, which I have already mentioned. If we look at it, how it stands now, the Global Nutrition Report 2018 revealed the prevalence of stunting, wasting, and overweight at the national level as 37.9%. If you think of the number of children we have, so that means several lakhs are suffering from stunting, several lakhs from wasting, and now we are also increasing the number who are overweight. This was the NFHS. I think most of you are well versed with the National Family Health Survey, which is a very representative survey carried out. And the last one was in 2014-15. So you can see that 38.4%, 21%, and 35.7% of children below 5 years were found suffering from stunting, wasting, and underweight, respectively. And you can see this trend. In fact, what is really worrying us is that the prevalence of wasting of children under 5 years is actually found to be increasing, which is why, I mean, we really have to think about it. Why is it happening so? And the fall is more or less now plateauing. We are not getting an impressive fall any longer. So which brings out to us to the hunger index. The hunger index, the composition is that it has 3 dimensions and 4 indicators. So there are 3 dimensions. Child undernutrition contributes 1/3, inadequate food supply contributes 1/3, and child mortality contributes to another 1/3 of calculating that index. And if you see, if we look at the green part only, because today we are coming to nutrition only. So child undernutrition, again, of this 1/3, we calculate it from wasting and stunting. And this goes beyond caloric availability. It considers aspects of quality of diet, utilization of diet. Suppose you give food, how much of that food reaches that child? What type of food reaches that child? Children are particularly vulnerable to nutritional deficiencies. And it is also, this index is also sensitive to uneven distribution of food within the household. Our traditional patterns of women eating last and least still pervades in many places. Children, they cannot snatch and eat, so naturally they get less. Even the older people suffer this. The elderly or the severely old people, they also suffer from the same problem. So these are the problems. So let's once again reiterate that food is about much more than nutrients. And some of the most important aspects of eating cannot be captured just with numerical metrics. What do we need to think about? There are several opportunities when we can make good this problem. The first opportunity which we have is the first 1,000 days of life. By first 1,000 days, we mean the 270 days of pregnancy when the child is within the mother's womb. The first year of life, another 365 days. The second year of life, another 365 days. It is this period during which we have the proper foundation and a good start. Proper nutrition, prevention of infections, age-appropriate psychosocial stimulation, including education, all give the best foundation. And unless it is provided during this period, if the start is not good, everything goes wrong. So why? Because these first 1,000 days are the time of tremendous potential and enormous vulnerability. It's a double-edged sword. If you can do it well, you have a very good population in future. But at the same time, if things go wrong, this is the period when the child has, the vulnerability is such that deficiencies during this period impact on a child's ability to grow, learn, and thrive. So you have done a lot of research, and there are other research in the fields of neuroscience, biology, and early childhood development, which has provided powerful insights for us into how nutrition and environments in the first 1,000 days shape the future outcomes. So as I said, proper nutrition in the first 1,000 days can cause or very good outputs, and at the same time, poor nutrition can cause irreversible damage to a child's growing brain. So they cannot perform well in school. They do not qualify to earn a good living. So they cannot come out of the cycle of poverty which permeates. And it can also set the stage for later metabolic disorders, obesity, diabetes, other chronic diseases. How? Poor nutrition for a mother affects both the unborn and the newborn baby. A low birth weight baby, if the mother is not nourished well, doesn't get proper food and proper amount and proper quality of food, proper types of food, she'll have a low birth weight baby. In fact, in our country, the weight gain during pregnancy, which should be about 11 to 12 kgs, why do we at all weigh mothers? For antenatal checkups, mother go and are weighed. But why? Because we want to see the gain of weight. If the mother gains proper weight, we assume that the child is going to have a proper birth weight. If the mother doesn't, in fact, in India, the average weight gain is only about 7 to 8 kg. So this low birth weight baby, which is less than 2.5 kgs at birth, is twice more likely to die from cardiovascular disease than one born with appropriate birth weight. This was based on the work done by Professor David Barker and his colleagues at Southampton University. He found that the root of diabetes is actually rooted before birth, because the pancreatic cells which make insulin develop in actually the mother's womb. And if the mother is undernourished, the programming is such that these cells are not properly developed. So the key to health is ensuring women eat well throughout their lives, especially during pregnancy and lactation. So as I said, 42.2% of Indian women are underweight at the beginning of pregnancy also. Not like you and me perhaps, but most of our women are actually very thin at the beginning of pregnancy, in contrast to 35% of non-pregnant women of childbearing age being underweight. And again, as I said, Indian women do not gain enough weight during pregnancy, only about 7 kgs. Social norms. This is beyond food. It accords young women low status in joint households. So they cannot ask, even if they are hungry, they cannot ask for extra food. So even within household, we find a nutritional deficiency or a differential happening. The National Food Security Act 2013 was formulated for this purpose, which legislates a universal cash entitlement for pregnant women of at least rupees 6,000. And this is a promising opportunity, because we find that just giving food always doesn't help. It has to have support in other forms. So it has found, the economic survey in 2015-16 said that we have to pair cash transfers with education, and that's what is happening now, because this was found that it will prevent and treat underweight and micronutrient deficiency in adolescent girls and will help in pregnancy weight gain. So programs have been formed for that. But what we really see that beyond nutrition, what happens is the dietary quality of women, particularly pregnant women, remains still poor. Eating habits remain uninformed. Social support is lacking. In distress situations like these, it is they who suffer most. Age, we still have a lot of teenage marriage, teenage pregnancies, education levels. Despite all our efforts, still the woman is largely illiterate in the vast population. Particularly knowledge regarding nutrition is very poor. So what we need is a lot more counseling based on evidence. Counseling primarily on promoting a healthy diet by increasing the diversity and amount. If you just increase a lot and have a lot of rice, it will not solve the problem. We need dietary diversity. We need adequate weight gain through sufficient and balanced protein and energy intake. It might not always be very expensive food stuff, but we need to have a diverse and balanced intake. Sorry. It has to promote consistent and continued use of micronutrient supplements. You know that through the government programs, we have a lot of food supplements and fortified foods. But again, utilization and access remain very poor. So available evidence suggests that nutrition education and counseling may support optimal gestational weight gain, reduce the risk of anemia, increase birth weight, and lower the risk of preterm delivery. So just supplying food is not enough. We need a lot more counseling. We have a lot of harmful practices all around. People, when they are pregnant, women, when they are pregnant, they avoid food items like papaya, mango, guava, etc. Even they reduce water consumption during postnatal period. In fact, this study, which was done in Karnataka, found that 89% of women thought raw papaya, ripe papaya, pineapple, fish, yam, egg, poultry, meat, all these are hot food. So if you have them during pregnancy, they believe it causes abdominal pain, uterine contractions, and miscarriage. This is a wrong concept. Again, 93% of the women in this study, they were found to believe that curd, butter, cheese, amla, grapes, all these are quite good in protein source and vitamins sources. Grapes, custard apple, GLBs, they are cold. So if you have that, mother will have cold and fever. And if you have it during lactation, it will cause cold and cough to the child. Once again, a wrong concept leading to lack of dietary diversity and deficiencies. More often, mothers choose foods that are high in fat. I'm happy that I chose this. In a study which we did last year only in our field practice area in Chingur, we find most of the pregnant women said that in the evening they were having muri and aloo chop, which was quite high in fats, particularly trans fats, and sugars, along with low-cost colors. So because of taste, cost, and convenience, they were having these, but causing irreversible damage, perhaps. So we need a lot more of nutrition education interventions, which emphasize tasty and affordable healthy substitutes, address these misconceptions, and counsel mothers about what they really need, the need for dietary diversity, the need to improve the diet quality. Why we keep on harping on the first 1,000 days is also because the most active period of neurological development in the fetus also happens in the first 1,000 days, fetus and newborn. Rapid change occurs from the first development of a structure recognizable as a brain. The first structure is recognizable on day 18. So from this day to age 2 years, the maximum neurological development happens, including that in the brain. So if you see this, you can see that this is how it happens. First, this part develops seeing, hearing, then the receptive language area. So what happens inside the mother's womb keeps on continuing till the child is up to 2 years of age. So important primary structures and processes, sensory systems, particularly auditory, visual sensations, the hippocampus, which is responsible for learning and memory, myelination that supports behaviors and actually provides the structures for later development. All these are developing now. Even the prefrontal cortex that is responsible for planning, attention, inhibition, multitasking, and all these circuits, they're developing. So if you see this picture down below of all the synapses, you can see the number of synapses a newborn has, then the number at 3 months, and the number of at 6 months. So you can see the numbers are increasing very fast. And this is very important because the faster it happens, the better it happens, the development is even better. So by 2 years of age, the brain has undergone tremendous restructuring. And however much you try to provide tonics, nutrients later on in life, at 3 years, 4 years, 5 years, it will never regain the deficiencies or the deprivation it has suffered from in the early 1,000 days. So that's why let us refocus our attention to the first 1,000 days, the first few months of pregnancy, then the breastfeeding during the first 6 months, solid food introduction from 6 to 12 months, and then the gradual transition to family diet after 12 months of age. Which again brings me to another thing which I thought should be emphasized is that of indicators of infant and young child feeding. Nothing is good there also. We have several indicators, how many children were initiated early, that is within the first hour of birth, to breastfeeding, how many children were exclusively breastfed, that is not even a drop of milk for the first drop of water for the first 6 months, only breast milk, continued breastfeeding, introduction of complementary foods, diversity, different types of diet introduced according to the different quality, meal frequency, minimum acceptable diet. And actually, you see, dietary diversity, there are 7 gross types of food groups. Of these, at least 4 types should be taken by the child. Then the frequency, there is a definite number. 2 to 3 times at the start, then 3 to 4 times by 9 months, and then more than 4 times after the child develops 1 year of age. And these two together formulate the minimum acceptable diet. And again, the consumption of iron-rich food. And all these indicators, we are faring badly. Basically, we are looking at, and this is actually a huge area, which I suppose requires one whole webinar to address. So I'll just touch upon these. We have been long looking at the Asian enigma. where we found that there was persistent and unusually high prevalence of child undernutrition in South Asia when we compare with countries of similar levels of income or economic growth. And when we tried to look into it, we found that there was a negative synergy between inadequate food intake and repeated infectious diseases, which again depended upon poor sanitation and high rates of open defecation. That leads to various kinds of infestations, infections, and environmental enteropathy. And even with all this Swachh Bharat Abhijan happening with Nirmal Bangla, and each state has its own way of focusing on it, still, for infants and young children, people don't think their feces are infective or I don't know what, but still, for children, open defecation seems the norm for very young children. Then there is poor coverage of health services still, poor implementation of nutritional programs and policies. Particularly, this COVID has shown us how these programs are so vulnerable to such pandemics and disasters, and there's things have gone haywire. And of course, the economic and social determinants. So what we have found is there are 5 top risk factors responsible for poor and insecure nutritional environments in the household. Short maternal stature, as we've said, that this happens right from low birth weight. The low birth weight girl grows up, adolescent girls are deprived in terms of food and nutrition, and then she becomes a mother of short stature. The cycle goes on. There comes another group which has extreme poverty. The rural population, especially agriculturists, still live in a state of uncertainty of income. Along with that, we have climate change. We recently had plagues of locusts. Then the multiplying effects of this pandemic. Together, this is pushing more people into hunger and poverty. Particularly smallholder farmers are struggling to feed their families, multiplying the crisis, and we expect that this can result in about 3 lakh people starving every day. Poor dietary diversity. By food, people feel that if my tummy is full, it's fine. It's not so. We must have different types of food. Mothers' lack of education, illiteracy, so that even if we have nutrition communication, people are not able to understand and follow that. Then coming to empowering women, even budgeting and discussions about investing in a healthy diet, hygiene, and sanitation. When women don't have a decision-making power in this, it's hardly ever effective to just go and talk to them about it. Child marriage remains one of the very important risk factors. Still, about 27% of girls are married before their 18th birthday. 7%, and this is just reported, this is the tip of the iceberg. And 7% are married before the age of 15. So India has the highest absolute number of child brides in the world. Isn't that embarrassing? Because a weak mother, the body is still not developed fully to bear a child, will give birth to a weak child. And this maintains the cycle of undernourishment. So what we are now looking at is, for this dietary diversity, we need to look into nutrition sensitive agriculture. People can grow more different types of food and sustain this. So this is another very important part, that is food security. Food security means food access. It means food availability in a consistent basis, not once in a month or twice a month you get food, or once a day you have food. No, it should be available, accessible, and again, it should be used appropriately based on the knowledge of basic nutrition and care, along with adequate water and sanitation. Nothing can happen in silos. Every department, every sector has to work hand in hand. So, these are various types. Perhaps we are in the margin of high food security, but there are people in this country who have very low food security, some with marginal, some with low. The country has developed a National Food Security Act, which ensures greater access to adequate quality of food at affordable cost, because we know the rationing system or the public distribution system is there. But when you evaluate that, we still find that the desired outcomes were not achieved because there is corruption. There is wastage of food grains in the godowns. So there are multitude of reasons why food as such is not bringing. We are growing a lot of food. We are one of the bumpers producers of food, but we are not being able to utilize it for efficiently improving nutrition of the community. So there are several programs. Before I end up, I would just like to touch upon these. in my department of the Ministry of Health and Family Welfare, there are several strategies. There are many others, like the Women and Child Development have the ICDA scheme. We have the Infant and Young Child Feeding Scheme under the National Health Mission. With every program, this is tagged. We have right from the ASHAs at the household level up to the block center, the hospitals, everywhere there are appropriate indicators, appropriate programs, but things are not happening properly. We have the Mother's Absolute Affection Program, MA program, to support this. We have various acts to facilitate promotion of breastfeeding. We have, I don't know whether you have actually seen, but we do have Village Health and Nutrition Days, where every month we have several days devoted in the outreach villages where people get together, mothers are brought there, children are brought there, along with other services. There is a lot of counseling supposed to happen actually. And if by perchance we have malnutrition or undernutrition and severe undernutrition, we have established nutrition rehabilitation centers. But see, the problems are not that we do not have programs. Problems are observed in distribution, in quality food. Again, one important thing which I thought we could focus on was like caste even. Caste causes a problem. Sometimes caste of the Anganwadi workers who are cooking the food. Beneficiaries have refused to consume food because lower caste people prepared it. So we are dealing with a country, a population which has this type of a complex web of causal factors. It's not only deficiency. So I think I'll round up by saying we are on our moving towards a goal. I do not know whether it will be achievable by time. We've already started staggering, and the COVID-19 has really set us all back all over the world. But nutrition is essential for success of development. It is not only economics. It is there in all aspects, all perspectives of our daily living. So the more we try to understand nutrition, not only understand, translate it into terms in which the common person would also understand, and try to improve utilization, access, availability, and distribution of the different programs, the different services, the different resources. I think a lot more is to be done in these areas. And I'm sure with all your good research and your efforts, this will be possible if we understand and if we hold hands and work in partnership. Thank you very much for your patient hearing. Thank you.
Amrita?
Thank you, ma'am. Thank you for this amazing lecture. This is so informative. Madam, there is some question.
Yes.
So, first one is how COVID-19 impacted health services for non-communicable diseases in our country.
Yeah. Well, though this is not directly related to nutrition in that sense, but yes, COVID-19 has impacted non-communicable diseases in two ways, I would say. One is from the provider aspect, because hospitals, healthcare facilities are now overburdened with COVID patients. The focus on non-communicable disease patients, the regular checkups, they have suffered. I would be actually hiding facts if I say things are as normal. No. And the second thing is that these comorbidities, people who are having these comorbidities are more vulnerable to COVID. So yes, they are suffering more from complications. They have more chance of mortality, particularly those who are elderly. And third, I would say it is also suffering. The nutrition part has also suffered because most of the people have been homebound. They have not been able to go out, do their regular checkups, have their normal type of food, which they can have. They are deprived from help in preparing food. And I mean, in every aspect, I think they have aggravated the disease process, actually reduced the possibility of regular screening, and has increased the vulnerability of these patients to COVID-19.
Thank you, ma'am. And what is the full form of IYCF?
Yes, it is Infant and Young Child Feeding, IYCF.
Okay, okay. Thank you, ma'am. Thank you once again.
I think there's just one more question. During the pandemic, how are the Anganwadi workers working for the mother and child nutrition programs? As of date, during the lockdown, the dry rations were supposed to have been provided at the household. The Anganwadi workers were supposed to go to the houses of pregnant, lactating women and children and supply them. But from this month, Unlock 4, the ICDS centers are going to open up. Yes.
Thank you, ma'am. With this, we come to an end of our lecture session for the
Thank
first
you very
day.
much.
I would request Dr. Purba Chattopadhyay ma'am to take over.
Thank you, Amrita. Ma'am, thank you so much for this enlightening lecture. One thing just comes to my mind was that because you are working directly in the field and dealing with this nutrition and these kind of women directly in from the field, what do you, just in a line, can you sum up the future directions and what are your observations? Are you hopeful?
Yes, public health people are always very optimistic because otherwise we cannot really work. But what I feel is all the knowledge that we have has to be translated into the field and imparted in terms which the common person will understand. It is, and again, as I said, just asking people to have something is not enough. You have to tell them why they should have it. And secondly, making that healthier substitute available, affordable, and accessible. Sometimes having the healthy food stuff is more costly. Definitely, fruits will cost you more than having a 5 rupee pack of chips. So, as long as that happens, but research can also give us healthier substitutes. So, I look forward to your research to give us these healthier substitutes, which can be made easily available. I'm sure the country has wonderful talent. So, in days to come, we will address it definitely.
Thank you so much. What a way to sum up our this webinar series, the day one. It has been such a nice thing, the first technology lecture, and then we move on to this trans facts lecture, and then we have Madam with us who is directly working in the field, sharing her experience, her vast domain of knowledge. Thank you so much, Madam, for summing up the entire thing. Our chat box, you can just go through it. There are so many good comments and people are so happy listening to the three wonderful speakers. Thank you all.
Thank you very much.
Purba, I will take I want to tell tomorrow we have two speakers, Dr. Subba Rao from NIN, and he will be talking on food labeling, which is a very, very important topic. And in the second session, we have Professor Rotimo Aluko, and he is the chief editor of JBC Journal, and he will be talking on protein and veg proteins for the kidney patients. And I think you should have we are lucky that we will get Professor Aluko in our webinar. Okay, thank you.
So we all part today only to meet tomorrow at 5:30. All the best. Good night, everyone. Have a good sleep, and then we again meet with fresh minds tomorrow.